Hello my dear students, this is Ikhlaq Sir Physics. So my dear students, I am back with lecture number 2 on electrostatics. Okay, so last time हमने पढ़ा था lecture number first. Okay, so what I have done is that I have divided this entire electrostatics into 3 different subchapters. That is lecture number part first, then part second, and then part third. Okay, so we are nearly done with the 30 or 35% of the electrostatics. Today, what we are going to discuss is the second part of the electrostatics. So here we are. तो देख लीजिए बेटा, यहाँ से हमने last time छोड़ा था. So we are going to start from here. That's equilibrium time. First and foremost, what this equilibrium means is that the point where the net electrostatic field is equal to zero or the electrostatic force will be equal to zero. ठीक? हमारे पास दो चार्ज पार्टिकल्स है बेटा, Q1 and Q2. What we are supposed to do is that we have to locate the point of equilibrium. ठीक है ना? So when these two charged particles, case first is that they are like. Like means that both are positively charged particles or both are negatively charged particles. ठीक है ना? The point of equilibrium that will lie between Q1 and Q2, first and foremost point. The reason is that यहाँ इस point पर कितने electric fields हैं? There are two electric fields. One is because of Q1 that will be towards right and because of Q2 that will be towards left. These two are equal and opposite. They will cancel, hence net electrostatic field at the point P will be equal to zero. Okay. Then this R1, actually we have to calculate the value of this R1 and R2, and value of R1 is given by this equation and value of R2 is given by the equation number second, which is root Q1 divided by root Q1 plus root Q2 multiplied by R. ठीक है ना? Some smart equations which are directly used to calculate the value of R1 and R2 or to locate the point of equilibrium. Alright, then it's obvious if for example there are 2 point charges and they are identical, that means Q1 is equal to 10 coulomb and Q2 is also equal to 10 coulomb. In that very case, the point of equilibrium will exactly lie at the midpoint. So that's what I am writing here. That is Q1 is equal to Q2. In that very case, this R1 will be equal to R2 and that will be equal to what? That will be equal to R divided by 2. Alright, सही है ना बेटा? Okay, so point of zero electric field lies between Q1 and Q2 and obviously it will be closer to the smaller charge. So case second देखेंगे बेटा. Let's have a look at the case second. Case second ये है that there are two charged particles. One is Q1, another is Q2, but one is positively charged particle, another is negatively charged particle. So in that very case, the point of zero electric field will exist on either side of the charges. ठीक है ना बेटा? तो point of equilibrium कहाँ पे lie करेगा? यहाँ तो यहाँ पे lie करेगा, यहाँ तो यहाँ पे lie करेगा. It cannot lie between Q1 and Q2 because, for example, there is point A which lies between Q1 and Q2. इस point A पर कितने electric fields होंगे? वहाँ पे दो electric fields होंगे because of minus Q1. That will be attractive in nature, because of plus Q2 that will be repulsive in nature. These two electric fields are in the same direction and it's never possible if there are two electric fields in the same direction that they will cancel each other. That's not going to happen. Okay, so that means the electric field somewhere between Q1 and Q2 cannot be equal to zero. It will be equal to zero somewhere on the either side, ठीक है ना? And will be closer to the smaller charge. Let's assume that this Q1 is smaller charge. So the point of equilibrium to exist करेगा वो यहाँ पे, क्योंकि यहाँ पे दो electric fields होंगे. Because of Q1 minus Q1 it will be attractive. Because of this plus Q2 it will be repulsive. These two are equal and opposite. So the net electric field at these 3 points at the point P will be equal to what? That will be equal to 0. ठीक है ना? Now you are again supposed to calculate the value of R1 and R2. So the equations are similar with a bit of difference. This is R1 that's equal to root Q1 divided by root Q2 minus root Q1 multiplied by R. And this equation gives you the value of R2 that's root Q2 divided by root Q2 minus root Q1 multiplied by R. ठीक है ना? Now it's obvious from this diagram, this is the value of R2 and this is the value of R1. So obviously R2 minus R1 किसके बराबर आएगा? R के बराबर. वो मैंने यहाँ पे लिखा that R is equal to R2 minus R1. ठीक है ना? और एक important point है, if for example there are two unlike charges and their magnitude is same. When their magnitude is same, then it's never possible that the point of equilibrium will exist. Okay? Because the reason is this, देख लीजिए बेटा, if for example this Q2 and Q1 they have same magnitude, then the denominator will become 0, then 1 by 0 is equal to infinity, so R1 will be equal to R2 will be equal to infinity. So we can say the point of equilibrium does not exist, or we can say the point of equilibrium exists at infinity. ठीक है ना बेटा? Let's do a couple of questions on this equilibrium, right? तो देख लीजिए बेटा, here we have example number 1. there are two charged particles, both are positively charged particles. One is 16e, another is 9e. We have to calculate the value of R1, R2, or we have to locate the point of equilibrium. So let's straight away use this equation. तो देख लीजिए बेटा हमारे पास इक्वेशन है क्या. R1 किसके बराबर है? That's equal to what? Root Q1 divided by root Q1 plus root Q2 multiplied by what? Multiplied by R. ठीक है ना बेटा? Okay. R1. अब यहाँ पे ध्यान रखिए बेटा. Since the two charged particles they are like, ठीक है ना? So which one you will take Q1 and which one you will take Q2, that's up to you. There is no hard and fast rule. All right? So Q1 किसके बराबर है? That is 16. So here I will write down root 16 divided by root 16 plus what? Root 9 multiplied by the total separation between the two charges, that comes out to be 14. ठीक है ना बेटा? So root 16 किसके बराबर है? That is equal to 4 multiplied by 14 divided by this is 4, this is 3. तो ये आएगा 7, 7 1, 7 2 is 14, 2 4 are 8 meters. तो R1 क्या निकला? 8 meters. And what about R2? R2 is obviously equal. What is the total separation? That's 14. What's R1 equal to? 8. तो R2 जो आएगा that will be 14 minus 8. So that is R minus R1, which is equal to 14 minus 8, and that comes out to be 6 meters. Alright, so we have calculated the value of R1 and we have calculated the value of R2. ठीक है ना बेटा? Okay, so let's switch to another example. This is our example number 2. In this very case, there are two charges, but these two charges are not like charges; they are unlike charges. ठीक है ना बेटा? तो देख लीजिए आप, Q2 is minus 36 coulomb and Q1 is plus 9 coulomb. In this very case, जब भी आप देखोगे that the charged particles are unlike, तब आपको क्या करना है बेटा? You will have to smaller charge, you will have to take smaller charge as Q1 और जो बड़ा वाला चार्ज है take that as Q2. ठीक है ना? So let's try to calculate the value of R1. तो R1 की इक्वेशन क्या बनेगी? That will be equal to root Q1 divided by बड़ा चार्ज that's root Q2 minus root Q1 multiplied by R. Point number first. Point number second आपको यहाँ पे ध्यान में रखना है, that is when you are taking the value of Q1 and when you are taking the value of Q2, just take their magnitudes. Okay, the reason is that under root of any negative number is an imaginary number. Okay, तो R1 देख लीजिए बेटा किसके बराबर आएगा? Root Q1, what is that? That is root 9 divided by root Q2, what is that? That is root 36 minus root 9 multiplied by what? Multiplied with the separation, and what is the separation? That is equal to 9. तो देख लीजिए बेटा R1 का वैल्यू क्या आएगा? Root 9 that is equal to 3 divided by root 36 is 6, root 9 is 3, 6 minus 3 is 3 multiplied by 9. तो R1 का वैल्यू क्या निकला? That is equal to 9 meters. All right? ठीक है ना बेटा? So R1 निकला 9 meters. ठीक? Now this is 9, this comes out to be 9 meters. That is R1, it comes out to be 9 meters. What you have to calculate is the value of R2. आराम से calculate कर सकते हो. तो जो R2 का वैल्यू होगा, that will be equal to R plus R1. ठीक है ना बेटा? अच्छा, value of R क्या है? That is 9. What about R1? That is 9. 9 plus 9 is equal to 18 meters. So the value of R2 comes out to be 18 meters. Hence we are done with calculating the value of R1 and calculating the value of R2. Alright. Okay. So next, a very important problem. ठीक है ना बेटा? And this question has been many times asked in the NEET and JEE maths. Very important question. And that's electrostatics. Simple harmonic motion in electrostatics. ठीक है ना बेटा? Okay, so have a look at this problem. First and foremost, there are two charged particles. That is capital Q and capital Q. And at the midpoint, there is a charged particle whose charge is minus Q और उसका जो mass है that is equal to m. Obviously, this charged particle will be in equilibrium. ठीक है ना? Because it lies at the midpoint. इस पे जो net force होगा that will be equal to 0. First and foremost. Next is that the question is given like this: the charged particle minus Q mass m is displaced along the y-axis. This charged particle is displaced along y-axis by a distance x whose value is very small compared to a. All right. Calculate the angular frequency and the time period of the charged particle. Have a look at this. यहाँ पे आप ध्यान रखिए बेटा. Concentrate here. पहले प्रॉब्लम को समझिए बेटा. This is a charged particle. It is displaced along this direction by some distance which is equal to x. And it is given that its x is very small compared to a. ठीक है ना बेटा? अब आप मुझे बताइए जो ये charged particle है which is minus q, how many forces are there on this charged particle? ठीक है ना? So there are two forces on this charged particle. One force will be because of this plus q and another force will be because of this plus q, isn't it? So this force is equal to F, and what about this? This is equal to F. ठीक है ना? So for example, this angle is theta, तो ये angle भी किसके बराबर होगा? थीटा के बराबर, ठीक है ना? Now what you do next is that resolve this F in the rectangular components. So in this direction there will be two components. One is this, that's F cos theta. F cos theta का एक कंपोनेंट यहाँ से होगा, that will be equal F sin theta. इस F का यहाँ से कंपोनेंट होगा F sin theta. F sin theta and F sin theta, they are equal and opposite, they will cancel. F cos theta and F cos theta, they are going to add because they are in the same direction, hence they are going to add. So in this PV direction, the net force comes out to be what? That comes out to be twice F cos theta. Okay, so next what I will do is this, I will try to calculate what is the net force on this particle. Okay, first and foremost, that's what I am going to do. मान लीजिए बेटा ये वाला डिस्टेंस है r और ये वाला डिस्टेंस भी क्या है r, सही है बेटा? Okay, so the net force on this charged particle, that is the net force, that is equal to what? That is equal to twice F into cos theta. ठीक, all right? So that's equal to twice F cos theta. That is equal to what? That's equal to twice F cos theta. Okay, so here I will write down the net force on this charged particle is equal to twice F cos theta. ठीक है ना? This force F, it will be given by the Coulomb's law, और वो किसके बराबर है? वो होगा बेटा 2k capital Q small q divided by what is this distance equal to? That is equal to r square. So ये ना बेटा multiplied by cos theta. Cos theta किसके बराबर होता है? That is equal to base divided by hypotenuse. Now when this is theta, base is x and hypotenuse r. तो यहाँ मैं लिखूँगा बेटा x divided by r. The force comes out to be equal to twice k capital Q small q into x divided by r cube. ठीक है ना बेटा? So this is net force. Now see that. Now it's given to me. This approximation is there. That x is very very small compared to a. यहाँ पे ध्यान रखो बेटा. When this x is very very small compared to a, so that means this point is very close to this point. तो उससे होगा क्या? उससे ये होगा this r will be approximately equal to a. R will be approximately equal to a. All right. So this equation will be something like this: 2k capital Q small q into x divided by a cube. ठीक है ना बेटा? So this is the equation, that is the net force on the charged particle. Now have a look on this force. अब जो ये force है, it has two very very special properties. Property number one is that this force is directed towards the mean position. See that it is directed towards the original position, which is point O. It is directed towards this mean position. Number one. Number second is that it is a linear function of displacement. That it is directly proportional to x. ठीक है ना बेटा? Number one is that it is directed towards mean position, and number second is that it is the linear function of displacement. That means this force, its behavior is same as that of Hooke's force, which is F equal to minus kx. Okay? ठीक है ना बेटा? So what I am going to write down is this, very very important. यहाँ पे आप ध्यान रखिए बेटा. What I am going to write down is this. The force here, that is equal to twice k capital Q small q into x divided by a cube. This is the force that is acting on a particle. Alright? And that's equal to, I will write down a generalized equation for linear simple harmonic motion. And what is that equation? That is m omega square multiplied by x. This is that equation, m omega square multiplied by x. This is that equation. Wait a moment. Just m omega square multiplied by x, where m is the mass of the particle and omega is the angular frequency of the particle, and x is what? That is the displacement of particle. This x and x is going to cancel. So here we are with the angular frequency, and what's that? That is under root of 2k capital Q small q divided by m into a cube, and hence we are done with this. So this is the angular frequency of the charged particle. And if you want to calculate time period किसके बराबर होता है? That is 2 pi by omega. So time period is equal to 2 pi by omega. So 1 by omega के बदले हम ये लिखेंगे, that is m a cube divided by twice k capital Q into small q. So this equation gives you time period of the charged particle. I'm sure this is very crystal clear to you. ठीक है ना बेटा? तो सबसे पहले हमने क्या किया? We have calculated the force, net force of the charged particle. Once we have calculated the force of the charged particle, this force, it has two important properties. Number one is that it's always directed towards mean position. Number second, it's a linear function of displacement. Both these are the conditions for what? For a force to behave as a Hooke's force, or for a particle to execute simple harmonic motion. ठीक है ना? So that is given by this equation m omega square x. This equation is the generalized equation for linear simple harmonic motion. Once you equate these two equations, x and x is going to disappear, तो वहाँ से omega आएगा, which is the angular frequency. So first equation gives you angular frequency, and the second equation जो यहाँ पे है, that gives you time period of the charged particle. Okay, तो आगे चलते बेटा. Next आप देख लीजिए. Next is this, that is these are the graphs between E and X. Again, a very important concept, but it is not that rocket science. तो आराम से आपको समझ में आएगा बेटा. यहाँ पे ध्यान रखिए. What we have to do is that we have to plot E versus X graph. First and foremost, you know that electric field due to the point charge is KQ divided by R square, and E versus R graph for a point charge will be always rectangular hyperbola. All right. So देख लीजिए बेटा, there are three different regions. Region number first, region number second, and region number third. First and foremost, let's focus on the region number first. यहाँ पे देख लीजिए बेटा, because of this charge, the electric field is repulsive, so that will be in this direction. Along this direction, this is the direction of the electric field, isn't it? ठीक है ना बेटा? अच्छा, because of this positive charge, electric field in this direction will be, in this region will be the same direction. Okay? Then in this region, because of this charge and this charge, electric field will be in this direction. That will be like this. So this is negative electric field and this is positive electric field. So this electric field is positive. Is that clear or not? Then these are 2 point charges, positive, and they are like charges. So that means the point of equilibrium will exist exactly at the midpoint. So somewhere here, this will be the point of equilibrium. And what we mean by that? That means the net electric field at this very point will be equal to 0. ठीक है? Now this is divided into two regions. अब यहाँ पे ये वाला region है और ये वाला region है. अब आपको देखना है इस region में what is the direction of electric field. यहाँ पर electric field because of this will be in this direction, which is positive, isn't it? So that's in this direction. So here I will write down like this. This is here positive electric field. All right. Then in this region electric field will be because of this more dominant because of this. ठीक है ना बेटा? तो इसकी वजह से जो इलेक्ट्रिक फील्ड होगा वो इस दिशा में होगा, इस दिशा में होगा. एंड इन दिस डायरेक्शन वी टेक पॉजिटिव, इन दिस डायरेक्शन वी टेक नेगेटिव. सो हियर दिस इज द डायरेक्शन ऑफ द इलेक्ट्रिक फील्ड व्हिच इज हियर माइनस. ऑलराइट, यहां मैं ऊपर बनाऊंगा दिस हियर नेगेटिव इलेक्ट्रिक फील्ड, तो यहां ऐसे बनाएंगे बेटा. सो दिस इज द डायरेक्शन ऑफ द इलेक्ट्रिक फील्ड व्हिच इज नेगेटिव माइनस. ठीक है ना? नाउ इजीली वी कैन प्लॉट E वर्सेस X ग्राफ. अब देखो बेटा यहाँ पे, सो दिस इज फर्स्ट ऑफ ऑल पॉजिटिव इलेक्ट्रिक फील्ड, तो ग्राफ ऊपर होगा. इट विल बी रेक्टेंगुलर हाइपरबोलिक ग्राफ लाइक दिस. दिस इज द ग्राफ. ठीक है बेटा? दिस नेगेटिव, तो इलेक्ट्रिक फील्ड ग्राफ जो होगा दैट विल बी बिलो द x एक्सिस, सो इट विल बी लाइक दिस. ठीक. देन दिस इज पॉजिटिव इलेक्ट्रिक फील्ड, तो ग्राफ जो होगा that will be above the x-axis. फिर यहाँ पे electric field will be below the x-axis. Okay, so the graph will be below the x-axis. The reason is that electric field here is negative. So this is your electric field versus x graph. Here it is electric field and here it is displacement, that's x, position x graph. ठीक है ना? Okay, so this was example number 1 on this. Next आप देख लीजिए. Here we have another example. ये हमारे पास एक positive charge है बेटा, ये है negative charge. You know that when there are unlike charged particles and they are equal in magnitude but unlike, equal and opposed, ठीक, then the point of equilibrium does not exist at all. अब यहाँ पे ध्यान रखिए बेटा, this is positive charge, इसकी वजह से जो electric field होगा यहाँ पे that will be repulsive in this direction, and this is negative charge, so because of this in this region the electric field will be towards right, but this will be dominant, तो इसकी वजह से जो electric field होगा that will be directed towards left, which implies it is negative. So here it is. This is the direction of electric field in this region, which is minus. सही है ना? Then this is negative charge. अब इस negative charge की वजह से जो electric field होगा that will be attractive in nature, और इसकी वजह से electric field होगा repulsive in nature. Dominant ये है. So electric field will be in this direction, exactly like this. Again it is negative. Simply take that electric field positive which is towards right and take that electric field negative which is towards left. As simple as that. Okay. Now because of the positive charge, electric field will be towards right. Negative charge, electric field will be towards right. So the two will add, and hence as a result of which electric field will be towards right, which will be positive. So this is plus E. सही है ना? Now easily we can plot the graph. अब आप देख लीजिए बेटा, यहाँ पे electric field negative है, तो इसका मतलब जो electric field का graph होगा that will be below the x-axis, तो graph कुछ ऐसे होगा. This will be the electric field graph versus distance. This is negative electric field, तो इसका मतलब it will be below the x-axis, so it will be distributed with graph. Alright, then this is positive electric field, so the electric field is positive, which means that it will be always above the x-axis. The graph will be somehow like this, because the reason is that electric field जो है at the charged particle, that's infinitely large. At the position of the charged particles, the electric field is infinitely large. The graph which ऐसे होगा, this will be the shape of the graph. Alright, so this is electric field versus distance graph. अब जो ये वाला क्वेश्चन है, आई एम श्योर दैट यू कैन डू दिस क्वेश्चन योरसेल्फ. ओके, और वी हैव रिपीटेड दिस क्वेश्चन. हाँ, ये तो हमने ऑलरेडी रिपीट किया है. ओके ओके, नेक्स्ट अगेन इंपॉर्टेंट टॉपिक बट इट इज वेरी इजी. ओके, तो यहाँ पे आप ध्यान रखेंगे. देख लीजिए बेटा, इट्स इलेक्ट्रिक फील्ड लाइन्स. फर्स्ट एंड फॉरमोस्ट इज दैट द कांसेप्ट ऑफ द इलेक्ट्रिक फील्ड लाइन्स was given by Michael Faraday to give a pictorial representation of the electric field, so that we can have a feel of this electric field. All right, and what's the definition of electric field line? Electric field line is actually just an imaginary line. It really does not exist. It's an imaginary line along which a positively charged particle moves when allowed freely to do so. For example, suppose that this is a positively charged sheet. मान लो बेटा, this is a positively charged sheet. This is a negatively charged sheet. ठीक है ना बेटा, this is a negatively charged sheet. Now what I am going to do is that I am going to release a charged particle, a positively charged particle. This is plus Q here. ठीक है ना? This positive charged particle, it will be repelled by this positive plate and attracted by this negative plate, isn't it? So it will move from positive negative in this direction along a straight line. This straight line is what we call as electric field line. This line, this trajectory or this path is what we call as electric field line. ठीक है बेटा? So this is exactly what we call as how we define electric field line. Okay, so here we are, the properties of the electric field lines. Property number first is that electric field line starts from positive charge plus Q and end at minus Q. ठीक? So plus Q it is called as the source of electric field and minus Q it is called as the sink of electric field. The next point is that electric field lines, they do not form the closed loops. They just start from plus and finish at the minus Q, and they do not form the closed loops like circular loops. Okay? So electric field intensity is directly proportional to density of field lines. What does that mean? That means, for example, there is point, जिस point पे density of electric field line ज़्यादा होगी, उस point पे electric field की intensity भी ज़्यादा होगी. Like this. देखो आप. So at this very point, the density of the electric field lines is very high, the spacing between the electric field lines is very low. So यहाँ पे density कम है, तो यहाँ पे electric field intensity ज़्यादा होगा compared to electric field intensity at the point B. ठीक? Next, the number of electric field lines drawn is directly proportional to the charge magnitude of the charge. What does that mean? That means, for example, you have two charges. One is 5 coulomb, another is 10 coulomb. If you draw 4 lines for the 5 coulomb, then the 10 coulomb that deserves how many lines? That deserves 8 lines. ठीक है ना? So that means more the charge, more is the number of electric field lines, and vice versa. Tangent to electric field line gives direction of electric field at that point. For example, ये आपके पास electric field line है, isn't it? Now हमने क्या किया? यहाँ पे एक tangent at this point, at this point, at this point we have drawn some tangents. Now tangent to the electric field line, this is an electric field line, and tangent drawn to electric field line at any point gives the direction of electric field at that very point. ठीक है ना? The next is that two electric field lines cannot intersect. For example, like this. So this is never possible that the two electric field lines intersect. Why? Why is it that the two electric field lines cannot intersect? The reason is that if, for example, they will intersect, then it would mean two different directions of electric field at that point of intersection. क्योंकि यहाँ पे दो electric field lines हैं, हम इस electric field line को tangent डालेंगे, हम इस electric field line को tangent डालेंगे. Now see that there are two different directions of electric field at the same point, which is point P, which is not possible. Okay, at one point P, there will be only one direction of electric field, and there will be only one magnitude of electric field. So what does that mean? That means two electric field lines can never intersect. It's not possible. ठीक है ना? The next is that point number 7 is electric field lines do not penetrate a conductor, but they penetrate an insulator. Simple सी बात है. For example, if you take a conductor, inside the conductor the electric field is equal to 0, which will be more clear later on जब हम पढ़ेंगे electrostatics of conductors. ठीक है ना. So inside a conductor electric field is always equal to 0 and hence the electric field lines they cannot penetrate a conductor but they penetrate an insulator. Inside the insulator the electric field is not equal to 0 but inside a conductor electric field is always equal to 0. ठीक. Now these are some representations. Okay, this is uniform electric field represented by the parallel lines, equispaced parallel lines. Now electric field at point A, B and C will be same because the density of the electric field line is that uniform. यहाँ पे density ज़्यादा है, यहाँ पे density कम है. Electric field at point A is not equal to electric field at point B. This is what you call as non-uniform electric field. Okay, then these are the electric field lines for positive charge, for plus Q, and these are the electric field lines for minus Q. You see that the electric field line they are coming out, radially outwards for a positive charge and going into the negative charge. That's why we say that this positive charge is the source of electric field and this negative charge is the sink of electric field. All right. नेक्स्ट आप देख लीजिए बेटा, फॉर एग्जांपल आपके पास ये है, दिस इज पॉजिटिव चार्ज, दिस अनदर पॉजिटिव चार्ज, बीच में इलेक्ट्रिक फील्ड क्या होगा बेटा, 0. दीज आर द इलेक्ट्रिक फील्ड लाइंस ड्यू टू 2 पॉइंट चार्जेस व्हिच आर 2 आइडेंटिकल पॉइंट चार्जेस. ठीक है ना बेटा, 2 लाइक पॉइंट चार्जेस रादर. सो दीज आर 2 लाइक पॉइंट चार्जेस एंड दीज आर इलेक्ट्रिक लाइंस. ठीक, this is a dipole, this for example plus Q and this is minus Q. The electric lines you see that they start from positive charge and then negative charge, but they do not follow closed loops. Start from positive and then negative. Start from positive and then negative. All right, these are field lines for a dipole. Now next important very important topic and that is electric dipole for you. ठीक है बेटा, तो इसमें जो टॉपिक नंबर फर्स्ट है वो है dipole moment क्या होता है, and then next is electric field due to dipole at axial position, number 1. Number 2 is equatorial position and number 3 is generalized position. We are going to discuss it in detail. Then talk on the dipole, another topic, and then potential energy of the work done on the dipole and angular simple harmonic motion of dipole. Let's discuss it in detail and one by one all these topics will be discussed. ठीक, तो सबसे पहले first and foremost some basic technical terms. The point number first जो आपको पता होना चाहिए वो ये है, होता क्या है electric dipole. So electric dipole is simply what is a system of two equal and opposite point charges separated by finite distance. ठीक है ना. For example आपके पास एक molecule है like NaCl, आपके पास एक molecule है HCl, आपके पास एक molecule है for example there is H2O. ठीक है ना. So there is a positive charge center and a negative charge center, and between these two positive and negative charge centers there is some separation, and such a system is called as what is called as dipole. ठीक है ना. Okay, these are some examples of dipole. Now electric dipole moment is a physical quantity which we define for an electric dipole जो आपने chemistry में भी पढ़ा होगा in the chemical bonding. All right. So how we define it? It is defined as a physical quantity whose magnitude is equal to the charge of the dipole and the dipole length. Dipole length simply means the separation between the negative charge and the positive charge. Okay, तो इसके बराबर होता है, this is your what, this is the dipole moment which is equal to charge of the dipole multiplied by what, dipole length. Is it a scalar quantity or a vector quantity? It's a vector quantity. What about direction? That is directed from minus Q to plus Q. ठीक है ना. फिर यहाँ पे हमने लिखा बेटा SI unit of dipole moment is that is coulomb meter. Dimensional formula इसका होगा बेटा L1, इसका होगा A1 T1, so it is L1 T1 A1. ठीक. Now there are two technical terms, that is what we mean by axial line and what we mean by equatorial line. The line that passes right through the dipole, that's called axial line, and the line that's perpendicular bisector of the dipole, that's called equatorial line. This very line, for example here I will draw a line like this. This line is what called as the axial line, and this line is perpendicular bisector of the dipole. This is what you call as the equatorial line. ठीक. Okay, a couple of examples on the dipole. So on the dipole moment let's try to solve these examples. तो देख लीजिए बेटा, concentrate here. Calculate dipole moment of the dipole. So example number 1 is like this. यहाँ पे कितनी चार्ज है बेटा, यहाँ पे चार्ज है -2q, यहाँ पे +q and यहाँ पे +q. First and foremost आप मुझे ये बताइए इस डायग्राम में कितने डायपोल्स हैं, how many dipoles are there in this diagram. So your answer should be there are 2 dipoles. Number 1 is this -q and +q forms one dipole. This -q and +q forms another dipole. Then the dipole moment is directed from y to y. It is directed from -q to +q. So this is one dipole moment. And this is another dipole moment. ठीक है बेटा. And what about the angle between these two vectors? that is 90 degree. आपको पता होना चाहिए whenever the angle between the two vectors equal vectors is 90 degree, their resultant is along the angular bisector and that is equal to root 2 into p. तो इन दो का जो रिजल्टेंट आएगा वो किसके बराबर आएगा, root 2 p. So that means the net dipole moment here will be equal to what? That will be equal to root 2 into p, while p is the dipole moment of one dipole. What's the charge of this dipole? That is q multiplied by whatever the length of this dipole, that is a. तो ये रहा इसका आंसर. So this is the net dipole moment of this system. Alright. फिर आप देखिए बेटा एग्जांपल नंबर सेकंड. Again, how many dipoles are there? There are two dipoles. Minus q plus q forms one dipole. This minus q, this plus q forms another dipole. So this is the dipole moment which is p. This is another dipole moment which is p. What about this angle? That is 60 degree because the triangle is an equilateral triangle. Alright. फिर आपको पता होना चाहिए जब भी आपके पास दो वेक्टर्स होंगे which are equal in magnitude and the angle is 60 degree, उनका जो रिजल्टेंट होगा that will be equal to root 3 into p. तो इन दो का जो रिजल्टेंट आएगा that will be along this direction which is root 3 into p. So let me write down here the net dipole moment is equal to root 3 multiplied by p and root 3 के बदले मैंने लिखा root 3 and dipole moment that is equal to charge of dipole multiplied by dipole length which is q multiplied by a. So this is the net dipole moment of this system. Alright, I'm sure this is crystal clear to you. आगे चलते बेटा. Next देख लीजिए electric field due to dipole. Now what we are supposed to do is that we have to calculate what is the electric field due to a dipole. Okay, at three different positions. One is called as equatorial position, second is called axial position, and third one is called as the generalized position. Okay, so first and foremost case first is that at a point on equatorial line. So this is called as the equatorial line which makes an angle of 90 degree with the dipole. ठीक है बेटा, यहाँ पे जो dipole moment होगा that will be equal to q multiplied by twice a plus a is equal to a. ठीक है ना. Now what we have to calculate is that we have to calculate electric field at this period point which is point P. ठीक. How many charges are here? Sir, there are two charges. कौन सा है वहाँ पे? Minus q charge and plus q charge. प्लस q की वजह से क्या इलेक्ट्रिक फील्ड रिपल्सिव होगा क्या अट्रैक्टिव होगा? रिपल्सिव होगा. माइनस q की वजह से फील्ड विल बी अट्रैक्टिव. सो बिकॉज़ ऑफ प्लस q इलेक्ट्रिक फील्ड इज डायरेक्टेड इन दिस डायरेक्शन. बिकॉज़ ऑफ माइनस q इलेक्ट्रिक फील्ड इज डायरेक्टेड इन दिस डायरेक्शन. नाउ फॉर एग्जांपल दिस एंगल इज थीटा, दिस इज थीटा, तो ये एंगल भी थीटा ही होगा और ये एंगल भी थीटा ही होगा. ठीक है ना बेटा. ओके, देन दिस e विल हैव टू रेक्टेंगुलर कंपोनेंट्स एंड दिस e will have two rectangular components. The sine components, that's e sin theta and e sin theta, they will be equal and opposite. This is the component of this, that is e sin theta, and इसका जो component यहाँ से होगा that will be equal to e sin theta. This e sin theta and e sin theta, they are equal and opposite, they are going to cancel. E cos theta and e cos theta, since they are the same direction, so they are going to add, and the net electric field at the point P is equal to 2e cos theta. So this is what I am going to write. The electric field at the equatorial line will be equal to what? That will be equal to twice E multiplied by cos theta. ठीक है ना. While E is the electric field due to one point charge and cos theta is simply base divided by hypotenuse. तो देख लीजिए बेटा क्या करेंगे यहाँ पे. Concentrate here. Let me first of all write down this here 2 and E is the electric field due to point charge. For example, this is point charge. इसकी वजह से जो यहाँ पे electric field होगा वो होगा बेटा k into q divided by distance, वहाँ पे है x, so k q by x square. And what about this cos theta? That is base divided by hypotenuse, which is equal to a divided by x. So here it is a divided by x. ठीक. So the electric field comes out to be what? It comes out to be twice k q into a divided by x cube. ठीक है ना. नाउ सिंपली व्हाट वी कैन डू इज दैट हम यहाँ पे पाइथागोरस थ्योरम यूज कर सकते हैं. जो ये x है इसका वैल्यू क्या बनेगा? इट विल बी इक्वल टू अंडर रूट ऑफ व्हाट? r स्क्वायर प्लस a स्क्वायर और a स्क्वायर प्लस r स्क्वायर. सही है ना. ओके, तो इलेक्ट्रिक फील्ड एट एक्सियल लाइन, यहाँ पे एट इक्वेटोरियल लाइन, यहाँ पे क्या आपके बेटा फर्स्ट आई विल राइट डाउन k दिस q into twice a, that is dipole moment. तो उसके बदले p लिखेंगे डिवाइडेड बाय x क्यूब. अब x के बदले क्या लिखेंगे? r स्क्वायर plus a square raised to the power 1 by 2. Then this here q, तो ये आएगा बेटा raised to the power 3 by 2. This is actually the electric field on the axial, on the equatorial line. Okay, this is the electric field wire and the equatorial line. ठीक. फिर यहाँ पे एक special case है बेटा. Let me write it down here. Special case. And that special case is, for example, the dipole is short. For short dipole. For short dipole, the dipole length is very small. Compute this x or compute this r. ठीक, तो इसका मतलब ये मैं लिखूंगा that this a is very small, compute r. When this a is very small, compute r, easily what we can do is that this r square can be neglected. So this a square can be neglected, compute r square. तो यहाँ पे जो electric field आएगा on the equatorial line, that comes out to be kp divided by r cube, because यहाँ पे क्या रहेगा r square, then 2 and 2 is going to cancel, तो यहाँ पे आएगा बेटा kp divided by r cube. This is the electric field at the equatorial line. Point number first, this is for the short dipole. Short dipole का मतलब when the dipole length is very small and it's a safe approximation, because for example you will take NaCl और आप लोगे HCl, वहाँ पे जो dipole length होती है that is of the order of angstroms, that's in angstroms, which is very small distance. Compute this distance if for example it's in centimeters or it's in meters and so on and so forth. All right, number one. Number second is that the electric field, this is the electric field on equatorial line, and the dipole moment which is directed in this direction from minus q to plus q. These two vectors are in the opposite direction, so I will write like this, that this electric field is at the equatorial line is anti-parallel. It is anti-parallel to what? To the dipole moment. Or the angle between them is what? That is 180 degree. And electric field to dipole is proportional to 1 by r cube. ठीक है बेटा? So this was electric field at a point P on equatorial line. ठीक है? आगे चलते बेटा. Next आप देख लीजिए. Next is the case second, that's at a point of the axial line. Now we have to calculate what is the value of the electric field at a point on the axial line. तो ये आपके पास एक डाइपोल है बेटा, which is minus q plus q, ठीक है ना? From the center to this the distance is equal to r. अब यहाँ से लेकर यहाँ तक ये डिस्टेंस कितना है? r minus a, और ये वाला डिस्टेंस कितना होगा? r plus a. डाइपोल मोमेंट किसके बराबर है? That is equal to q multiplied by twice a and is directed from minus q to plus q, directed towards the right. ठीक है ना बेटा? This is your dipole moment. ठीक. अब पॉइंट P पे कितने इलेक्ट्रिक फील्ड्स हैं? वहां पे सर दो इलेक्ट्रिक फील्ड्स होंगे. कौन सा इलेक्ट्रिक फील्ड होगा? बिकॉज ऑफ प्लस q इट विल बी रिपल्सिव, बिकॉज ऑफ माइनस q इट विल बी अट्रैक्टिव. नाउ सिंस दिस प्लस q इट इज क्लोजर टू द पॉइंट P, तो इसकी वजह से जो इलेक्ट्रिक फील्ड होगा उसका मैग्नीट्यूड ज्यादा होगा, बिकॉज इलेक्ट्रिक फील्ड इज इनवर्सली प्रोपोर्शनल टू r स्क्वायर. सो दैट मींस दिस E1 it must be greater than E2. When E1 is greater than E2, so the net electric field will be in the direction of E1. This is the electric field EA, means axial line, which will be equal to E1 minus E2. This is the net electric field of the axial line, isn't it? So what I am writing is this, that the electric field at the point P, which is called an axial point. So here I will write down the axial electric field. यहाँ पे आप ध्यान रखिए बेटा. So what I am going to do is that I am going to calculate the electric field on the axial line, denoted by what? Denoted by EA. That's obviously equal to E1 minus E2. Now what is the electric field due to a point charge? Electric field due to point charge is equal to KQ divided by distance square. आप मुझे पहले बताइए यहाँ से लेकर यहाँ तक ये distance कितना है? That is R minus A. ठीक. So E1 is simply equal to KQ divided by R minus A whole square. Minus what is the electric field at the point P because of this minus q, that is equal to kq divided by what? What about distance? वहाँ पे r plus a whole square. ठीक है? Okay. Now this will be obviously kq common. Cross multiplication ये आएगा बेटा r plus a whole square minus r minus a whole square whole divided by this into this r minus a into r plus a whole square. ठीक है बेटा? This is the net electric field. All right. ठीक. Okay. Now you know that a plus b whole square is equal to a square plus b square plus 2ab. What about a minus b whole square? That's a square plus b square minus 2ab. Once you solve this and this, the exact result you will get is this. It will be simply equal to 4 times ra, because a square will cancel with a square, b square will cancel with b square, twice ra and twice ra, that will end to become 4 times ra. डिवाइड, फिर आपको पता होना चाहिए a minus b into a plus b होता है किसके बराबर? a square minus b square whole square. All right. So this is the electric field on the axial line. ठीक है? Now what about dipole moment? Dipole moment किसके बराबर है? That's q into twice a. So this will be equal to, पहले हम 2 लिखेंगे into k, 2 into k, फिर आएगा बेटा q multiplied by twice a, that's equal to p, then there is r divided by all this, which is r square minus a square whole square. This is the electric field due to the dipole on the axial line. On the axial line. ठीक है बेटा? Again there is a special case, and what is that special case? That is, what about short dipole? So here I am writing that. Here I am writing that for short dipole. For short dipole, what about electric field? What about electric field for the short dipole? ठीक है बेटा? For short dipole, this r is very small compared to a. Very large compared to a, or a is very small compared to r. Then in that very case, this a square can be neglected. तो यहाँ पे जो आएगा that will be r raised to power 4. Then 1 r will cancel. तो electric field जो axial line पे आएगा due to the short dipole, that will be twice kp divided by r cube. This is the electric field due to the short dipole proportional to what? 1 by r cube. ठीक है? And it is 2 times more what जो electric field है on the axial line. Let me write down here in the bracket. The electric field in the axial line is parallel to dipole moment. That's parallel to dipole moment. Alright, so we are done with the electric field at a point on equatorial line and at a point on axial line. आगे चलते बेटा. Next is what we are going to calculate is that we have to calculate electric field at generalized position. Generalized position implies that position which is neither axial nor equatorial. So ये वाले position में बेटा this line is called axial line, this line is called equatorial line, but this is generalized position. So at the point P, we have to calculate what? We have to calculate electric field, but this equation is true only for short dipole. Okay, so you tell me what is the electric field. देख लीजिए बेटा, सबसे पहले मैंने क्या किया? Dipole moment which is equal to Q multiplied by twice A, where this length यहाँ से लेकर यहाँ तक, this is A, this is point O, this is equal to A. तो dipole moment किसके बराबर है? That's equal to charge multiplied by dipole length, and be directed from -2 to +2. It's a vector quantity. What I have done is that I have resolved this in the two rectangular components. This P. तो यहाँ से जो component होगा that will be P cos theta, और यहाँ से जो component होगा that will be equal to P sin theta. Then concentrate on the point P. जो point P है बेटा, it lies on the axial line of P cos theta, and it lies at the equatorial line of P sin theta. Equatorial line of P sin theta, because this is perpendicular here. You see that these two lines, they are mutually perpendicular. So point P पे दो electric fields होंगे. There will be electric field because of P cos theta which will be axial in nature, and there will be electric field because of P sin theta which will be equatorial in nature. ठीक है बेटा? अब now what is the electric field due to the axial? वो किसके बराबर होता है? वो होता है बेटा 2kp divided by r cube. लेकिन यहाँ पे मैं जो लिखूंगा बेटा p के बदले क्या लिखेंगे? P cos theta, isn't it? This is the electric field due to the P cos theta at the point P, and that will be in this direction, because you know that the electric field on the axial line is parallel to the dipole moment. Point number 1. Point number 2. अब बचा P sin theta. तो P sin theta जो है in this point P, it lies on the equatorial line, since it is perpendicular to it. It lies on the equatorial line on P sin theta. So the electric field at the point P, because of P sin theta, will be equatorial in nature, and equatorial electric field जो होता है, that is anti-parallel to the dipole moment. Have a look at this. Have a look at this. This is the electric field of the equatorial line which is anti-parallel to the dipole moment. So that means the electric field due to the P sin theta will be equatorial in nature, and I will write down like this. That is EE. That's equal to what? Equatorial होता है बेटा KP into sin theta divided by what? Divided by R cube. So yeah, na? Now the net electric field. Now see that these two electric fields, that is axial and equatorial, they are mutually perpendicular. When they are mutually perpendicular, इनका जो resultant होगा, that will be equal to E, which will be equal to what? Under root of EA square plus EE square. So you know बेटा, this is the net electric field at point P. अब इन दो में से देखो बेटा कॉमन है क्या? So E will be equal to what is the common? That is KP by R cube, and that will be out of this root. So KP divided by R cube. ठीक है ना? Under root of what? What's left? 2 square, that's equal to 4. ठीक है बेटा? Then this is cos theta, इसका square आएगा 4 cos square theta plus then what's left here is sin theta. तो ये आएगा बेटा sin square theta. This will be sin square theta. Now you know that cos square theta plus sin square theta is equal to 1. तो ये जो आएगा it will be KP divided by R cube under root of 3 cos square theta, and cos square theta plus sin square theta is equal to 1. This is the net electric field due to the short dipole at a generalized position. कहाँ पे आएगी बेटा? at the generalized position. This is the net electrostatic field, which is equal to this Kp divided by r cube into 3 cos square theta plus 1. Now you tell me, for example, this point P is at the axial line. तो यहाँ मैं लिखूंगा बेटा on axial line, what is the value of this theta? ये theta क्या होता है? Theta axial line का obviously होगा 0 degree. And what about this cos 0? That will be equal to 1. 3 plus 1 is equal to 4. तो root 4 जो आएगा बेटा, that is the electric field of axial line, which is equal to twice Kp divided by r cube. And equatorial line, if for example this point P lies on the equatorial line, when it lies on equatorial line, then in that very case theta का वैल्यू क्या होगा? What will be the value of theta? That is equal to 90 degree. ठीक है ना बेटा? Okay, so cos 90 is equal to 0. So 0 plus 1 comes out to be what? That's equal to 1. तो ये electric field किसके बराबर आएगा? On the equatorial line, this electric field will be equal to what? That will be equal to Kp divided by r cube. So this is the electric field on the equatorial line, and this is the electric field on the axial line. Okay, so I'm sure this is crystal clear to you. क्या किया मैंने? Dipole moment I have resolved that the rectangular components P cos theta, P sin theta. This point P, it will act as the axial point for the P cos theta and will act as the equatorial point for the P sin theta. So at the point P there will be two electric fields, one due to P cos theta, another due to P sin theta. Due to P cos theta, the electric field will be axial in nature, hence parallel. And due to P sin theta, electric field at the point P will be equatorial in nature and hence anti-parallel. Then the resultant of these two will be the net electric field. ठीक है बेटा, तो आप यहाँ पे पहले देख लीजिए, we have summarized these results somewhere. So this is the summary. So first and foremost, this is the dipole moment, which is called charge multiplied by dipole length, and electric field due to the axial line is this, that is 2 Kp divided by r cube. Equatorial line by electric field किसके बराबर होता है? Kp by r cube, asked in NEET 2020. And generalized position is Kp divided by r cube into under root of 3 cos square theta plus 1. Important point: electric field on the axial line is parallel to dipole moment. Electric field on the equatorial line is anti-parallel to dipole moment. Electric field due to dipole is proportional to 1 divided by r cube. Again, important point. And electric field on the axial is electric field on the equatorial will be equal to 2:1. Electric field on the axial is equal to 2 Kp by r cube. This is 1 Kp by r cube. If we divide the two equations, you will get the ratio that is equal to 2:1. So that means if, for example, the electric field on the equatorial line at some distance is equal to suppose 10 Newton per coulomb, then the electric field on the axial line at the same distance will be equal to 20 Newton per coulomb. Okay, and what about the angle? Angle between the electric field on the axial line and equatorial line is equal to 180 degree. Simple reason: electric field on the axial is parallel to dipole moment, and electric field on the equatorial is anti-parallel to dipole moment. So what about the angle? That is 180 degree. Okay, so next जो है बेटा, next topic हमारा है, and that is what? That is, let's place this dipole in the uniform electric field. So concentrate here. Dipole is placed in a region of uniform electric field. First and foremost, this uniform electric field is represented by equispaced parallel lines. Uniform electric field का simple मतलब ये है, suppose that there are two opposite walls in a room. तो एक wall जो है बेटा that is positively charged and another wall is negatively charged. Now the electric field lines that will be directed from positive to negative, and the electric field in between the two walls will be a constant electric field or a uniform electric field. Now what we have done is that हमने यहाँ पे एक dipole किसमें रखा? In this uniform electric field. Now you know that whenever a charged particle is placed in a region of electric field, it will experience a force, and that force will be equal to charge multiplied by electric field, because electric field किसके बराबर होता है? Force per unit charge. And if you want to calculate force, that will be equal to charge multiplied by electric field. Okay, so here it is, this here positive charge plus q, and this here another negatively charged particle. This will experience a force of plus QE towards right in the direction of electric field. This is negatively charged particle. It will experience a force of QE in the opposite direction, in the direction opposed to electric field. अब देखो बेटा, these two forces are here. They are equal in magnitude. ठीक है बेटा, but they act in the two different like exact like this is a dipole. This is positive charge. This is negative charge. इस पे जो force है that's towards right, और इस पे जो force है that's towards left. What will happen to the dipole is that it will tend to rotate the dipole and will tend to this electric field, and it will tend to align the dipole in the direction of the electric field. Okay, so in doing so, what will happen to the dipole is that it will execute simple harmonic motion. This is what's going to happen to the dipole like this. it will execute simple harmonic motion. Okay, so first and foremost what we are going to do is that we have to calculate what will be the torque on the dipole. ठीक है बेटा, अब इस डाइपोल पे कितने चार्जेस हैं? दो चार्ज हैं, तो कितने फोर्स है वहां पे? दो फोर्स है. सो दिस फोर्स एंड दिस फोर्स दे फॉर्म अ कपल. एंड व्हाट्स द परपेंडिकुलर डिस्टेंस बिटवीन देम? दैट इज दिस इज 2a, दिस इज थीटा. तो ये आएगा बेटा 2a sin थीटा, बिकॉज़ sin थीटा इज परपेंडिकुलर डिवाइड बाय हाइपोटेन्यूज. तो परपेंडिकुलर जो इसका आएगा वो आएगा 2a sin थीटा, व्हिच इज r परपेंडिकुलर. देन हियर लेट मी राइट इट डाउन. दिस इज टॉर्क व्हिच इज इक्वल टू व्हाट? r परपेंडिकुलर मल्टीप्लाइड विद फोर्स. दिस इज व्हाट यू कॉल एज फोर्स r. ठीक है, तो r परपेंडिकुलर किसके बराबर है? दैट इज ट्वाइस a into sin theta. What about the force? Force is equal to q into e. Then easily I can write it like this: q multiplied by twice a multiplied by e into sin theta. सही है बेटा? So this is torque. All right. Now what I can do is that the torque जो dipole moment यहाँ पे है, इसका जो dipole moment है, that's equal to charge of the dipole multiplied by the dipole length, which is equal to twice a. So q into twice a, it can be replaced by p into e sin theta. So this is the torque on the dipole, which is pe into sin theta. Clear हो गया? While p is what? P is the dipole moment. And what about this e? E is the electric field, and theta is the angle between dipole moment and the electric field. Now you know that a cross b किसके बराबर होता है? वो होता है a b sin theta, और a b sin theta is in turn equal to a cross b. So in the vector form we can write it like this. This is torque vector that's equal to p vector cross e vector. ठीक है ना बेटा? In vector form this is torque, which is equal to p cross e. All right. ठीक है बेटा? So this is torque that is acting on this dipole. We have calculated this equation. Next हमारे पास क्या है? Next we are going to calculate what's the potential energy of the dipole. Now see that whenever a dipole is placed in a region of uniform electric field, what this electric field does is that it will tend to rotate this dipole. In rotating the dipole attains some kinetic energy, some rotational kinetic energy. Now the question arises, why that rotational kinetic energy comes from? That comes from the potential energy. Now the question arises, why that potential energy comes from? That comes from the work done, which is done by the electric field on the electric dipole. That's what we are going to do. तो यहाँ पे ध्यान रखिए बेटा. तो ये आपके पास एक uniform electric field है, denoted by E. And here we have what? This is a dipole. This is a dipole. This is minus q and this is plus q. This dipole obviously it will rotate. Now for example it rotates by very small angle. Then we will calculate what is the small work done. So that is dw is equal to tau into d theta. ये इक्वेशन मैंने आपको पढ़ाई है बेटा, या ये आपने ऑलरेडी पढ़ी होगी in the rotational mechanics. ठीक है? In the translation of motion, work done is called force into displacement, and the rotational mechanics, the work done is called torque into angular displacement. All right. So this is dw. And what about this torque? ये torque किसके बराबर है? It's equal to p into e sin theta. This is dw. All right. Now if I am interested in calculating what the net work done, what I do is that I integrate both sides. So integration of dw is equal to p into e integration of sin theta d theta. This is actually the small amount of work done when the dipole is rotated by some very small angle, which is d theta. And this is the total work done. So here it is w is equal to p into e. What about the integration of sin theta? Difference of sin theta is cos theta. Integration of sin theta is minus cos theta. So let me write it here. This is minus cos theta. And what about the limits of integration? Theta 1 and theta 2. ठीक है? So the work done on the dipole will be obviously equal to what? That is equal to minus p into e multiplied by cos theta 2 minus cos theta 1. So this is the amount of work done in rotating the dipole. ठीक है? Which is minus p into cos theta 1, cos theta 2 minus cos theta 1. ठीक है ना? Okay. What I am going to do is this. Before defining potential energy, I will define what we call as reference point. And reference point is that point where the potential energy is taken to be 0. So I will write like this. If theta 1, if initially the dipole is perpendicular to the electric field, that means theta 1 is equal to 90 degree, and then theta 2 that's equal to some angle which is theta. So initially dipole is like this, in this very position. Side the dipole moment is upwards and electric field is towards the right. What's the angle? 90 degree. तो cos 90 किसके बराबर होता है? 0 के बराबर. So the potential energy will be equal to work done, which will be equal to minus pe into cos theta, or potential energy can be written like this. It is equal to minus p dot e. This is the equation for the potential energy of the dipole in a uniform electric field, that is minus P dot E, or that's equal to minus P into E cos theta. Alright, and if you want to calculate work done will be equal to what? Change in potential, and that's equal to delta U, which is obviously equal to minus PE into cos theta 2 minus cos theta 1. That is the equation for the work done. Okay, so here we have this, our equation number first is, which gives the work done in rotating a dipole from initial angle theta 1 to final angle theta 2, and this equation number second, gives you what is the potential energy of the dipole when it's placed in a region of uniform electric field. Okay, so this is a summary. ठीक है ना, the torque on this equal to P sin theta, इस पे क्वेश्चन आया था NEET 2023 में. Then potential that's equal to minus P cos theta, or you can write down this equal to minus P dot E. Here you can write down like this as well, minus P dot E. What about work done? That's P cos theta 1 minus cos theta 2, or you can write down minus P into cos theta 2 minus cos theta 1. Okay, now next is that, next यहाँ पे जवाब के बेटा, next हमारे पास क्या है? I am going to add it here. तो यहाँ पे concentrate कीजिए बेटा, have a look. That is angular simple harmonic motion, angular SHM on dipole or dipole, ठीक, in electric field, or rather in uniform electric field. Okay, so whenever what I do is that I place a dipole in a region of uniform electric field, there will be force on this positive charge, on this negative charge, I say like this, ठीक है ना, it will tend to align the dipole in the direction of electric field, but here it has some momentum, it will overshoot the mean position, and now there will be force on this in this direction. So what this torque will tend to do is that it will tend to rotate this dipole. The dipole will execute simple harmonic motion, it will execute simple, and that will be angular simple harmonic motion. Now what I have to calculate is, calculate angular frequency and time period of dipole. Angular frequency and time period of dipole. This is what I am going to calculate. ठीक है ना बेटा? So you tell me what's the torque on the dipole? Sir, वो तो है PE sin theta. All right, this is the dipole. This is the torque on the dipole. Now suppose that this dipole is slightly displaced by very small angle. So here I will write down if theta is very small. If theta is very small, like 1 degree, 2 degree, 3 degree, in that very case जो ये sin theta है, it can be easily replaced by theta. For very small angle, sin theta is equal to theta. ठीक है, तो torque इसके बराबर आएगा, it will be equal to PE multiplied with theta. Now have a look at this torque. This torque has two important properties. Number one is that it will always tend to bring this dipole back to the equilibrium position. Number one. Number second is that it is directly proportional to theta. That it's a linear function of angular displacement, and the situation is right for angular simple harmonic motion. ठीक है बेटा, तो torque इसके बराबर है PE into theta. So let me write down here this torque, which is equal to PE theta, is equal to, I will write down here an equation that's called as generalized equation for angular simple harmonic motion, and that is I into omega square multiplied with theta, where I is the momentum inertia of the dipole, omega is the angular frequency, and theta is the angular displacement. So this theta and theta is going to vanish. I omega square किसके बराबर आएगा? PE के बराबर. So that means omega comes out to be under root of PE divided by momentum inertia, which is equal to I. So this is the angular frequency of the dipole. Number one. Number second is that you want to calculate time period. So time period किसके बराबर होता है? Time period होता है 2 pi divided by omega, which is equal to, so time period is equal to what? That is equal to 2 pi in the reciprocal of this, which is equal to I divided by P multiplied by E. So this is the torque. This is the time period of the dipole. Okay, so hence easily we have calculated what's the angular frequency and what's the time period of the dipole. Okay, so we are done with this. Okay, then next what I have done is that I have summarized all these equations, 13 different equations on the dipole on a single page. Okay, so you can see it here. Next, आगे चलते बेटा. Let's do a couple of examples on the dipole, on the different expressions. Okay. Before we move to the examples, there are some special cases. तो देख लीजिए बेटा. special case is first this theta is equal to 0 degree, 180 degree and 90. This theta is the angle between what and what? Dipole moment and electric field. ठीक है. अब टॉर्क किसके बराबर होगा? अच्छा टॉर्क किसके बराबर होता है? इट्स इक्वल टू P is sin theta. Sin 0 0, sin 180 0, sin 90 1. So the torque will be equal to 0. Sin 90 is 1. So torque will be equal to P into E. Potential energy cos 0 is 1. Potential किसके बराबर है? minus TE cos theta. ये तो आपको पता है. This is equal to what? This potential energy is equal to minus PE into cos theta. And what about this torque? Torque is equal to P into E into sin theta. Isn't it? This is torque. This is called P sin theta. So cos 0 किसके बराबर 1. So potential is equal to minus P into E. And cos 1 it is minus 1. तो potential किसके बराबर आएगा? That is equal to plus PE. Cos 90 is equal to 0. So potential energy will be equal to 0. Okay. Then the type of equilibrium, when the potential energy is minimum, then the dipole is in stable equilibrium. It is in stable equilibrium. ठीक है बेटा? Okay. When the potential energy is maximum and the torque is equal to 0, then we say that it is an unstable equilibrium. The dipole is an unstable equilibrium. Okay. And the case number 3, when the angle is 90 degree, you see that the torque is not equal to 0, means that it is in inequilibrium. It is not in equilibrium, it is in inequilibrium. It is in inequilibrium. Alright? Okay. Let's move ahead. तो देख लीजिए बेटा important points. There are a couple of important points. ठीक है. Point number first is this. Whenever you place a dipole in a region of uniform electric field, the net force on the dipole will be equal to 0. Okay, because there are two equal and opposite forces, they will cancel each other. Net force will be equal to 0. That is why the center of mass of the dipole always remains at rest. That does not get displaced from its position. All right. And net torque जो है, that may or may not be 0. Okay, if angle is equal to 0 degree or angle is equal to 180 degree, then torque will be equal to 0. Otherwise, for any other angle, the torque is not equal to 0. Then, if the dipole is placed in non-uniform electric field, the net force on the dipole will not be equal to 0. Okay. Then net torque that may or may not be equal to 0, and the net force on dipole is equal to this, that is minus P into d by dx, where P is the dipole moment and dE by dx is the rate of change of electric field with respect to the distance. So here it is. This is A. Dipole is placed in a region of uniform electric field. See that the force on this charged particle is plus QE and the force on this charged particle is in this direction. That is called minus QE. They are equal and opposite. They will cancel. Net force on the dipole will be equal to 0. This is another dipole placed at an angle. See that the net force is equal to 0 and the net torque is not equal to 0. इसमें torque भी 0 है because theta is equal to 0 degree. ठीक है. Now here we have this dipole placed in a region of uniform electric field, non-uniform electric field. So this non-uniform electric field, the net torque will be equal to 0. Why? The reason is the इस पे जो force होगा plus that will be in this direction, and इस पे जो force होगा that will be in this direction. Okay. But this F1 and F2 are not equal because E1 and E2 are not equal. Hence the net force is there, which is equal to this. That is minus P into d by dx. This is the force on the dipole. And net torque will be equal to 0 because the torque created by the F1 and F2 will be equal to 0. In this very situation, there is some angle which is theta, so the net force will not be equal to 0 and net torque will not be equal to 0. So in nutshell, I will say like this, that whenever you place a dipole in a region of uniform electric field, the net force on the dipole will be equal to 0, net torque may or may not be 0. And if a dipole is placed in a region of non-uniform electric field, the net force will not be equal to 0 and net torque may or may not be 0. Okay. So here we have this NEET 2021 question, and it is simply conceptual question. सिर्फ आपको ये बताना है what is the direction of the force on the dipole. ठीक. तो यहाँ पे dipole है, this is plus q, this is minus q. Plus q पे जो force होगा, there will be force on this plus q, and that will be in this direction, which is equal to F1. Minus q पे जो force होगा, that will be opposed to electric field, so that will be in this direction, which is equal to F2. Now see that this F1 will be greater than F2, isn't it? Because यहाँ पे जो electric field है, density of electric field lines is more, means that E1 will be greater than E2, and hence F1 will be greater than F2, and hence the net electric field on the dipole, that will be equal to what? F1 minus F2, F1 minus F2, and the net force will be directed towards the right. This is the net force and will be directed towards the right. So it is directed towards the right. All right, ठीक है बेटा? I'm sure that this is clear to you. So the net force here, that's equal to what? That's equal to F1 minus F2, and this force is directed towards the right. Okay, so another example. Example number 1. ये देख लीजिए बेटा आप. Example है क्या? Example is simply like this, that for a short dipole you have to calculate the electric field, ratio of electric field at x equal to and x equal to 4 meters. First and foremost, you must know that electric field due to the dipole is proportional to 1 by r cube, या लिख सकते बेटा 1 by x cube. ठीक है ना? So what does that mean? That means this E1 divided by E2 will be equal to x2 divided by x1 whole cube. This is what it means. ठीक? अब x2 का वैल्यू क्या है? That's equal to 4 and x1 का वैल्यू क्या है? That's equal to 2. तो यहाँ पे आएगा बेटा 4 divided by 2 whole cube. ठीक है ना? 4 by 2 is 2, 2 cube is 8. तो ये आएगा 8 divided by 1. So that means E1 is E2 will be equal to what? That will be equal to 8 is to 1. Okay? So this is the answer. ठीक है? Electric field is simply proportional to 1 divided by r cube. Have a look at this example. तो ये वाला एग्जांपल आप देख लीजिए. Dipole moment is given, electric field is given theta. That is the angle between the dipole and the electric field, that is 30 degree, and you will have to calculate what torque and potential energy. हम बताइए बेटा टॉर्क किसके बराबर होता है? What's the magnitude of torque? That's equal to P E sin theta. Easily we can do it. हाँ, dipole moment का वैल्यू क्या है? What's the value of dipole moment? That is 2 multiplied by electric field किसके बराबर? 40 sin 30, that's 1 by 2. इसका जो आंसर आएगा that will be 40 न्यूटन मीटर. All right. Then the potential energy किसके बराबर होता है? minus P into E cos theta. Let me write down here dipole moment. What's that? That is 2. What about electric field? क्या वैल्यू है इसका? 40 into cos 30. Cos 30 is equal to root 3 divided by 2. 2 and 2 disappears, so that it is minus 40 under root 3 joule. This is the potential energy of the dipole, and this is the torque acting on the dipole. Easy question था बेटा. Okay, so another question is like this. Dipole moment is given, electric field is given. You will have to calculate what is the work done in rotating the dipole from theta 1 equal to 30 degree to theta 2 equal to 60 degree. Write down the equation for the work done. What's the equation for work done? That is like this. PE multiplied by cos theta 1 minus cos theta 2. सही ना बेटा? Okay. Dipole moment का वैल्यू क्या है? What's that? That's equal to 2. Electric field that's equal to 10 multiplied by cos theta 1, that's cos 30 degree minus cos 60 degree. अब cos 30 किसके बराबर होता है? That's root 3 divided by 2. Cos 60 1 divided by 2. तो यह आएगा बेटा 2 into 10 divided by 2 multiplied by root 3 minus 1. Okay, joule. This is the amount of work done, and 2 and 2 is going to cancel. The work done जो निकलेगा that's equal to 10 multiplied by this is here 1.7 approximately minus 1 joule. Now see that 1.7 minus 1 is 0.7. 0.7 into 10 is 7 joule. So the answer will be 7 joule. So the work done is what? That is 7 joule will be the work done on the dipole. All right. आगे चलते बेटा. Have a look at this. This question has been asked in the NEET 2023. Electric field given, torque given, theta given, dipole length given, and you will have to calculate what the charge at the dipole. Okay, I will write down the equation and you will try this question yourself. Simply torque किसके बराबर होता है? That's equal to P into E into sin theta. And dipole moment is what? That's equal to charge multiplied by dipole length into E multiplied by sin theta. What you will have to calculate eventually is the charge of the dipole. That will be equal to torque divided by length of the dipole multiplied by electric field multiplied by sin theta. Everything is given. Just put the values in this equation and get the answer. Okay, so we are done with this with the dipole. ठीक है ना? So next topic जो है again a very important topic, and that is electric field due to the continuous charge distribution. And example number 1 here is a charged ring. Okay, so charge continuous charge distribution. What does that mean? That means here we have two different systems. One we call as discrete system, another we call as continuous system. Discrete system or n particle system is that system which contains finite number of particles, like 2 particles, 4 particles, 10 particles, so on and so forth. Continuous system is that which contains vanishingly small and infinitely many number of particles. Okay, and if you want to calculate electric field because of the continuous system, what you will have to do is the integration. Okay, so here we have this charged ring. इस पे जो total charge दिया गया है that's equal to plus q. The total charge of this ring that's equal to what? Plus q. Like this is a positively charged ring. What we have to do is that हमें क्या करना है? We have to calculate the electric field at the point P. Okay, what we have to do is that we have to calculate electric field at the point P. So let's try to do that. तो देख लीजिए बेटा electric field at point P कैसे calculate करेंगे. First of all, there will be, now for example, let's imagine that this is one charge element whose charge is equal to dq. This another charge element whose charge is equal to dq. इस dq की वजह से यहाँ पे electric field होगा that will be equal to dE, isn't it? और इसकी वजह से यहाँ पे electric field ऐसे होगा that will be also equal to dE. Okay, so dE is the electric field because of dq. All right, now this dE, now this angle is theta, this angle is theta, so resolve this dE in the rectangular components. तो यहाँ से दो components होंगे, those will be twice dE into cos theta. This d is sin theta and this d is sin theta. They are equal and opposite, hence they will cancel. So the net electric field जो होगा that will be contributed by the cos theta components and not by the sin theta components. Alright, so electric field at the point P जो होगा that will be equal to integration of dE cos the components. dE cos the electric field along this direction. Okay, so I will integrate, not do dE cos theta, but I will integrate dE cos theta. Okay, while dE is what we have the electric field due to a point charge. Point charge की वजह से electric field जो है that is k into charge is dq divided by distance वहाँ पे जो है बेटा that is equal to r square multiplied by what? Multiplied by cos theta. Now the electric field at point P, यहाँ पे ध्यान रखिए बेटा, integration of this dq is equal to q. तो electric field क्या निकला? That is kq into cos theta divided by r square. The problem is done. This is the electric field due to the ring, which is kq cos theta divided by r square. फिर इस cos के बदले हम लिख सकते हैं that's equal x, that is base divided by hypotenuse, which is x by r. तो electric field की और एक इक्वेशन बन जाएगी kq into x divided by what? Divided by r cube. Or for that matter, what you can do is this: you can replace this r, जो ये r है ये किसके बराबर है? It's equal under root of x square plus a square. Simply I use what? Pythagoras theorem. तो यहाँ पे electric field किसके बराबर आएगा? kqx divided by what? r के बदले under root, तो ये आएगा बेटा x square plus a square raised to the power 3 divided by 2. So this is the electric field at the axial line or on the axis of a uniformly charged ring. ठीक है ना? Then what we have to do eventually is that just memorize one equation. Just memorize one equation. I am going to highlight it here for you, and that's the electric field due to the ring at the point P will be equal to, what is the electric field due to point charge? That's kq divided by r square multiplied simply by what? Cos theta. This will be the electric field due to the uniformly charged ring. That is kq divided by r square, same as the point charge multiplied by what? Cos theta. ठीक है बेटा? If this ring becomes very small, it becomes a point. Then in that case, this theta will be equal to 0 degree. इसमें आप put करो बेटा theta equal to 0 cos 0 आएगा 1. Electric field will be same as that of point charge. Alright? Okay, आगे चलते हैं बेटा. So next मैंने यहाँ पे लिखा electric field due to the ring is equal to this, that is kq divided by r square multiplied by cos theta, or kq into x divided by r cube, and electric field at the center of the ring will be equal to 0. और ये मैक्सिमम कहाँ पे होता है? At x equal to plus minus a by root 2. You can expect this question directly. Derive हम नहीं करेंगे, otherwise we can derive. What you have to do is that you have to differentiate this electric field with respect to x and equal to 0. तो वहाँ से x का वैल्यू ये निकलेगा plus minus a by root 2, and electric field is equal to 0 at the center of the ring, and the graph will be like this. ठीक है? Simply because suppose that this is a ring, this is a ring. ठीक? Positive charge. यहाँ पे जो electric field होगा that will be towards right, so that is positive. यहाँ पे जो electric field होगा that will be towards left, so that is negative. At the center, what's the electric field? That's equal to 0. Okay? So maximum it's at plus minus a by root 2 यहाँ पे, और यहाँ पे electric field क्या होगा बेटा? That will be maximum. That is maximum at plus minus a by under root 2. At the center, electric field is equal to 0, and this is your E versus x graph for a uniformly charged ring. ठीक? तो आप याद रखो बेटा, point number first is that electric field due to the uniformly charged ring is called kq cos theta divided by r square. Number one. Number second is that it is 0 at the center. Number third is that it is maximum at plus minus a by under root 2, and the graph is simply like this. Alright, so we are done with the electric field due to the uniformly charged ring. अब next जो है बेटा, that is we have to calculate electric field due to the circular arc and the rod. ठीक, तो यहाँ पे क्या दिया गया है, lambda दिया गया है, that is linear charge density which is charge per unit length. Okay, that's called as lambda. Electric field यहाँ पे जो होगा, that will be directed along the angle bisector away from the positive charge and towards the negative charge. और यहाँ पे जो इलेक्ट्रिक फील्ड होगा that will be along the angle bisector that's equal to E. And electric field चाहे यहाँ पे आपको निकालना होगा या यहाँ पे निकालना होगा, it will be same. And what is the important result? That is this 2k lambda divided by r into sine of theta by 2. This is the electric field due to the uniformly charged circular arc or due to this rod and this very point at the point P. Alright, this is point P, so this is the electric field at point P, or this is point P, this is the electric field at point P. The answer is same for the example number 1 and for this very example. For these two examples, answer is exactly same. It is 2k lambda by r into sine of theta by 2. और क्या कर सकते हैं? What you can do is that you can always replace this lambda by q divided by l and k by 1 by 4 pi epsilon naught. Okay. तो नेक्स्ट आपको क्या निकालना बेटा, यू हैव टू कैलकुलेट इलेक्ट्रिक फील्ड ड्यू टू दिस चार्जर और रॉड एट दिस वेरी पॉइंट एट द पॉइंट P. यहां से लेकर यहां तक ये डिस्टेंस दिया गया है, दैट्स कॉल्ड r, एंड यहां से लेकर यहां तक ये डिस्टेंस किसके बराबर है, l. आप मुझे बताइए, नंबर 1 इज दैट व्हाट यू कैन डू इज दैट यू कैन गो फॉर द इंटीग्रेशन. On integration you will get the result, but there is a shortcut way to calculate the electric field because of this. You tell me what is the electric field due to a positive point charge. यहाँ मैं लिखूँ बेटा, what is the electric field due to a point charge, that is kq divided by r square. kq divided by r square. इसी r square को हम replace करेंगे. We will replace this r square by r into r plus l. अब यहाँ पे ध्यान रखिए बेटा, if the length of this rod becomes equal to 0, if it becomes equal to 0, इस पे जो charge है बेटा that is equal to q. So if it becomes equal to 0, then in that case it will be a point charge. So when the L is equal to 0, kq divided by r square same as the point charge. ठीक है ना? So this is a direct way to memorize the equation for this. Otherwise you have to integrate it. तो integration भी कर सकते हैं. What you have to do is that you have to chop this into many pieces, calculate electric field because of one such piece, and then you will have to integrate it. You will eventually get the same result. Okay, but that is not important for us. That integration is not important for us. Okay, so simple सा ऐसे है. Let's take this for example. This is an element. इसका जो charge है बेटा that's equal to what? That is dq, and the length of this that's equal to dx. Alright. Now electric field because of this at that very point, distance यहाँ से यहाँ तक जो है बेटा that's equal to what? That's equal to x. So dE will be the electric field because of this element that's equal to k into charge is dq divided by what? Distance square, so that's equal to x square. Now this dq lambda, you know that lambda is defined as charge per unit length. इतना तो पता है ना? And that's in turn also equal to dq divided by dx, where dq is the charge of this and dx is its length. तो क्या लिखेंगे? k into lambda into dx divided by x square. Alright. Then if you want to calculate the net electric field, you will have to integrate this. तो देख लीजिए बेटा, net electric field E will be equal to k into lambda is a constant integration of x raised to the power -2 with respect to x. ठीक है? So x raised power -2 का इंटीग्रेशन क्या आएगा? x raised power -1 divided by -1. तो इसका जो रिजल्ट आएगा that will be equal to minus k lambda into 1 by x. And what about the lower limit and upper limit? Lower limit of x is equal to, यहाँ पे x का वैल्यू क्या है? r. And what about this? X here is equal to r plus l. So the lower limit is r, upper limit is r plus l. ठीक? Then upper limit minus lower limit will give the net electric field. तो ये आएगा बेटा minus k into lambda into upper limit is what? That is 1 divided by r plus l minus lower limit is what? 1 divided by r. So ये बेटा नेगेटिव साइन से ये पॉजिटिव बनेगा और ये नेगेटिव बनेगा. So let's do that. That's k into lambda into what? 1 by r minus 1 divided by r plus l. Isn't it? ठीक है बेटा. Okay. Now cross multiply. So r plus l minus r. R and r will cancel. तो l k into lambda l is q. तो ये आएगा बेटा finally kq divided by r into r plus l. This is the electric field due to this charge or what? अब आप याद कैसे रखोगे? What is the electric field due to the point charge? सर वो तो है kq by r square. इसी r square को रिप्लेस कर लो किससे? r into r plus l such that if this rod is a point charge, इसकी जो length है that is 0, r plus 0 is r into r is r square, तो ये बन जाएगा बेटा kq by r square. So the electric field due to the charged rod is simply what? That is kq divided by r into r plus l. Whether you integrate it or you don't integrate, that hardly matters. What is relevant here is the end result. Electric field due to the charged rod. What is that? kq by r square. R square को किससे replace करना है? r into r plus l. That is it. Okay, so next जो हमारी problem है that is electric field due to the charged disk. Sigma is given. Sigma means surface charge density, which is Q divided by A, charge per unit area. This is given to you, and we have to calculate what is the electric field due to this charged disk at this point. Okay, so directly I will write down the result. Well, इसका result here बेटा that is sigma by 2 epsilon naught into 1 minus cos theta. This is the electric field due to this charged disk. All right. तो फिर ऐसे भी लिख सकते हैं, we can write like this, sigma divided by 2 epsilon 0 into 1 minus cos का होता है बेटा किसके बराबर? Base divided by hypotenuse, that's equal to x by r. X divided by r, ऐसे भी लिख सकते हैं. This is the electric field. या फिर we can write like this as well, sigma divided by 2 epsilon 0. It will depend upon the options. 1 minus x divided by this r is in turn equal to under root of a square plus x square. Pythagoras theorem. तो यहाँ पे क्या लिखेंगे बेटा? Under root of a square plus x square. This will be the electric field. This is electric field due to the charging disk. अब सिर्फ एक क्वेश्चन याद रखोगे, sigma by 2 epsilon 0 into 1 minus cos theta. Cos के बदले मैंने क्या लिखा? x divided by r. R के बदले मैंने क्या लिखा? Under root of a square plus x square. So this is your electric field due to the uniformly charged disk. So next topic very important, and that is Gauss's law. Okay, now different topics in the Gauss's law are so Gauss का मेरा पहला टॉपिक है बेटा that is area vector. ठीक है ना? So easy topic है, यहाँ पे आप ध्यान रखिए. First and foremost, what is the definition of area vector is that it is a physical quantity whose magnitude is called area plane, and the direction will be always perpendicular to the plane. To the plane. All right. So here where this is square, अच्छा इस square का तो area आपको पता होना चाहिए. What is that? Area is equal to 2 into 2 is 4 meter square. All right. Now what about area vector? Let me write down here. Area vector is equal to 4 meter square. ठीक है ना? And this area vector is always perpendicular to the plane. So that's like this. Okay. So directed outwards means that it is dot. Yeah, it is directed along the negative, along the positive z direction. So it is here kk. Unit vector kk. This is the area vector. ठीक है ना? Simply area vector क्या करना है आपको? Calculate the area of the plane. Then it's always perpendicular to the plane of this area. All right. So this is the plane. So here we have this is area vector which will be directed outwards. Now let's calculate the area. Area is equal to length into breadth. 6 2s are 12. इसका जो area आएगा that will be 12 meter square. And in the vector form you can write it like this. This is here 12 meter square multiplied by what? Multiplied by kk. kk means it is directed vertically outwards. ये देख लीजिए बेटा जैसे ट्रायंगल का एरिया तो आपको पता होना चाहिए, that is 1 by 2 base into height. And what is base? 6. And what about height? 6 5 are 30 divided by 2 is equal to 15 meter square. So what about area vector? Area vector जो है बेटा that is equal to 15 meter square directed outwards. So here I am writing k here. All right. Then this is circle का तो पता होगा बेटा आपको. So that is what? That is pi r square. इसका area होता है, the area is equal to pi r square. It is directed vertically outwards, so the area vector will be equal to pi r square into kk. अब kk is a unit vector directed along the positive z direction. ठीक है ना? इसी तरह से आपके पास फॉर एग्जांपल दिस क्लोज्ड फिगर. ठीक. So we'll define here vectors, area vectors. So for this plane area vector will be directed like this. For example a1. ठीक है. For this PE surface area vector is directed in this direction. Suppose that is equal to a2. For this PE surface area vector is directed vertically upwards, and for this surface area vector is directed vertically downwards, which is a4. All right. So पहले सबसे पहले आप बताइए बेटा 3 into 5 is what? That is 15. So area is equal to 15 meter square directed along the x-axis. So here I will write down a unit vector that is I. In the same way, इसका जो एरिया बेटा this is 3 meter, तो इसका मतलब ये भी होगा 3 meter and this will be 5 meter. 3 5s are 15, तो इसका जो एरिया आएगा that will be minus 15 meter square into I. अब इसका एरिया कैलकुलेट कीजिए बेटा. So this length is 2 meter, that means this length will be also equal to 2 meter. This is 3 meter, that means this side will be 3 meter. 2 into 3 is 6, तो ये जो आएगा बेटा it will be 6 meter square along the y direction. So here it will be JE. Alright, so this is A3 vector, this here A1 vector, and this A2 vector. Now A4 vector आप देख लीजिए बेटा, this is here 2 3s are 6 directed vertically downwards, so that's along the negative y direction, which is minus 6 meter square into JK. These are different vectors. ठीक है बेटा, तो आप यहाँ पे ध्यान रखिए बेटा, that is for an open surface the area vector is always perpendicular. Whether you take it outwards or you take it inwards, it's your choice. But for the closed figure, the area vector is always directed outwards, and its magnitude is what? That is magnitude is equal to the area of the plane, and its direction is always perpendicular to the plane of the surface. Next is electric flux. Again an important topic, electric flux. ठीक है बेटा, what we are trying to do is that we are making preparations for the Gauss's law. तो पहले सबसे पहले हमने क्या पढ़ा? एरिया वेक्टर. So I'm sure that area vector is crystal clear to you. उतना ज़्यादा tough concept नहीं है, बहुत ही easy concept है. Now what about electric flux? Electric flux is defined like this. It is defined as the number of electric field lines passing through any plane. That is defined as electric flux. So number of electric field lines passing through a plane is called as electric flux. ठीक है बेटा? Okay. Now there are different cases. Case first is that electric field is uniform and electric field area they are parallel to each other. That means theta is equal to 0 degree. यहाँ पे ध्यान रखना बेटा, यहाँ पे ध्यान रखना. Now for example, there is any rectangular sheet. It is placed in a region of uniform electric field. Number of electric field lines passing through this plane will depend upon two parameters. Number one, the intensity of the electric field. जितना electric field intensity ज़्यादा होगा, more will be the number of electric field lines passing through the area. Number one. Number second is that it will also depend upon area. जितना ज़्यादा area होगा plane का, तो उतना ज़्यादा flux होगा. ठीक? So I will write like this. That is flux is simply equal to what? E multiplied by E. ठीक है बेटा? So that's equal to E multiplied by E. So electric field is uniform and this is the area. So flux किसके बराबर होता है? That is electric field multiplied by what? Multiplied by the area. Is directly proportional to these two physical quantities. ठीक? But this is true only if electric field is constant. Number one, that is uniform, and the theta जो है that's equal to 0 degree. Only under these two conditions it is true. Okay. Now case number second is that electric field is uniform, but it's not necessary that the theta will be equal to 0 degree. तो यहाँ पे आप ध्यान रखिए बेटा. This is A. The sheet is like this and electrical lines are these. What's the angle? That is theta. तो क्या मैं बोल सकता हूँ बेटा जो ये A है इसका यहाँ से क्या कंपोनेंट होगा? That is A cos theta. Now can I write like this? That is flux. जो यहाँ पे flux होगा that will be equal to electric field multiplied by the component of the area vector which is parallel to electric field. So E into A cos theta is simply what? That is the dot product of the electric field and the area vector. So this is the flux through a surface. Okay, but this equation again true only if electric field is uniform, that is constant. Electric field क्या होना चाहिए? Uniform. Only then you can write down the dot product of the electric field and the area vector. This is another equation for you. This equation number third. Now this is more generalized. That is electric field is non-uniform. Now it's not necessary that the electric field is uniform like this. This is a non-uniform electric field. यहाँ पे electric field intensity ज़्यादा है, यहाँ पे electric field intensity कम है. And this is what I have done is that जो ये area है, this area A, what I have done is that I have broken it into many pieces. I have chopped it into many pieces, and DA is one such area element. आप मुझे बताइए इस DA का इस दिशा में कितना कंपोनेंट होगा? That will be DA cos theta. This flux through this, so I will write like this. The flux through this very small area, that is d phi, is equal to E multiplied by dA multiplied by cos theta. Or what you can write down is this: d phi is equal to E dot dA, dot product of the electric field and the area vector. And if you want to calculate the total flux, just go for the integration. Integration of d phi is equal to integration of E dot dA. So that means the net flux through the surface will be equal to integration of E dot dA. This is the net flux through the surface. ठीक है बेटा? So you tell me how many equations are there to calculate the electric flux. There are exactly 3 different equations. Equation number first is this. Let me write it like this. That is flux is equal to E multiplied by A. Equation number second you have to calculate the flux is what? That is the dot product of the electric field and the area vector. And equation number third is what? That flux is equal to integration of E dot dA. But this equation is true only if electric field is constant and theta is equal to 0 degree. And this equation is true only if electric field is constant, and this equation is always true. It's a more generalized equation. The equation number third is a more generalized equation. It is true when electric field is uniform. It is true when electric field is non-uniform. If, for example, electric field is uniform, then what you can do is that you can pull this E out of the integral, and integration of dA जो बनेगा बेटा, that will be equal to A, hence the flux will be equal to E dot A. So these are the equations to calculate the flux. 3 different equations to calculate the flux. ठीक है बेटा? And for closed surface, if you want to calculate the flux for a closed surface means, for example, there is a sphere or a cone or a cylinder, so on and so forth. In that case, the flux for a closed surface will be given by this integration of E dot dA. यहाँ पे जो मैंने circle डाला इस integral पर, इसका मतलब है for a closed surface the flux is given by this, that's equal to integration of E dot dA. This is for open surface, this is for closed surface. All right. So how many equations for the flux are there? There are exactly 4 different equations to calculate the number of electric field lines passing through any area, and that's what we call as electric flux. Okay. So next बेटा important points यहाँ पे मैंने लिखे. Point number first is that flux entering is taken as positive and flux leaving is taken as negative. थोड़ा सा यहाँ पे change करना बेटा. The flux entering is taken as negative. I'm sorry. Flux entering is taken as negative and the flux leaving is taken as positive. When the flux leaves the surface, it is simply like this. देख लीजिए आप. For example, here we have this is a cuboid. ध्यान रखो बेटा. Concentrate here. This is a cuboid. And these are the electric field lines. These are electric field lines like this, exact like this. Okay. So for this very surface, see that the electric field is directed towards the right, and the area vector is also directed towards the right. What is angle? 0 degree. Cos 0 किसके बराबर होता है? 1 के बराबर. So the flux is positive and it's leaving. And for this very surface, जो ये वाला surface है, इसके लिए जो electric field है, that is towards right. And what about the area vector? That's always directed outwards, so that's towards left. What is this angle equal to? 180 degree. Cos 180 होता है बेटा negative. So the flux leaving is taken as negative, and the flux entering is taken as negative, and the flux leaving is taken as positive. यहाँ पे आप देखोगे बेटा phi L, and flux leaving is taken as positive. Okay. So point number first, point number second. And flux is equal to 0 if electric field is perpendicular to the plane of surface, obviously, because then theta जो होगा that will be equal to 90 degrees. Simply like this. Suppose that this is an area vector and these are the electric field lines which are going parallel to the surface. So that means angle जो यहाँ पे है, that is not equal to 0 degree. That is equal to 90 degree, because these are electric field lines. And this is area vector which is directed radially out, which is directed outwards towards you. The angle between this E and A will be 90. Cos 90 0 होता है. Hence the flux through this surface will be equal to what? That will be equal to 0. Okay. This is a quick portion. Yeah, what's so good? ऐसा यूनिट ऑफ फ्लक्स किसके बराबर होता है? फ्लक्स इज इक्वल इलेक्ट्रिक फील्ड मल्टीप्लाइड बाय एरिया. इलेक्ट्रिक फील्ड का जो यूनिट है, the unit of electric field is Newton per coulomb, और एरिया का जो यूनिट होता है बेटा that is मीटर स्क्वायर. तो ये बनेगा न्यूटन मीटर स्क्वायर पर कूलम, एंड डायमेंशनल फार्मूला विल बी दिस. ओके. तो नेक्स्ट आप देख लीजिए बेटा एग्जांपल्स. एग्जांपल नंबर 1, कैलकुलेट द फ्लक्स. यू हैव कैलकुलेट फ्लक्स फॉर दिस एरिया. मान लो बेटा इसका जो साइड है दैट्स इक्वल टू A, length and breadth that's equal to AA, and the electric field is given to you that's equal to E. Now first and foremost, you tell me what is the angle between the electric field and the area vector. is that equal to theta? Is that this theta? Not at all. That is this theta is equal to here 90 degree, because जो area vector है बेटा वो ऐसे है, that's perpendicular to the plane. So that's like this, that is dot. This is area vector and this electric field. What's the angle? 90. जब angle 90 होगा, flux will be equal to E into A into cos 90 degree. Cos 90 is 0 and the flux is equal to 0. Alright, in the same way, suppose that this is a surface, suppose this is a plane, and these are the electric field lines. Again, for this, what is the angle between this electric field and this area vector? That is 90. So the flux will be again equal to 0. The reason is that the field lines, they are passing parallel to the surface and they are not penetrating into the surface. ठीक है बेटा, अब देख लीजिए बेटा एग्जांपल नंबर सेकंड. In the example number second, a cube is placed in the region of uniform electric field. What we have to calculate is flux entry, flux leaving, and net flux through the object, through this very object. We have to calculate what is the flux entry, what is the flux leaving, and what is the total flux. यहाँ पे आप ध्यान रखिए बेटा, यहाँ मैं एक शॉर्टकट टेक्निक आपको दिखाऊंगा, वो ये है. That is flux. If an object, so here let me write like this. Let me write like this. मैं ऐसे लिखूँ बेटा. जब भी हम ऑब्जेक्ट को कहां पे रखेंगे बेटा, इन अ यूनिफॉर्म इलेक्ट्रिक फील्ड, द फ्लक्स एंटरिंग और फ्लक्स लीविंग विल बी इक्वल टू व्हाट? दैट विल बी इक्वल इलेक्ट्रिक फील्ड मल्टीप्लाइड बाय एरिया ऑफ प्रोजेक्शन, एरिया ऑफ प्रोजेक्शन और एरिया ऑफ शैडो. ठीक है बेटा. नाउ let focus on this. So these are electric field lines. So this is another electric field line, like this, it is passing through this electric field line. अब आपको कैलकुलेट क्या करना है? We will have to calculate what is the flux. अगर आप यहाँ से लाइट ऑन करते बेटा, what will be the shadow of this? इसकी जो प्रोजेक्शन बनेगी वो कुछ ऐसी होगी. This will be the projection of this. इसकी प्रोजेक्शन ऐसी होगी. This will be the projection. ठीक है बेटा. अच्छा, इसका साइड जो बेटा that's equal to A, length breadth that's equal to A, तो ये A आएगा और ये A आएगा. Then what about the area of this projection? इसका जो एरिया होगा that is equal to A square. Okay, now you know that flux entering is taken as negative, so that's equal to minus E multiplied by A, which is equal to minus E into A square. Alright, where A is the area, so flux is passing through this, ये वाला side जो है बेटा, ये वाला side इसका area A, and flux entering is at this very surface, so this electric field and this area vector, and flux entering is negative, that's equal to minus E into A square. What about flux leaving? That will be obviously plus E into A square. Alright, and what about the total flux? The net flux will be equal to what? That is equal to 0. Total flux will be equal to 0. Okay? So A part is done, that is flux entering minus C square. Flux leaving is positive, and the total flux will be equal to 0. Simply like this, if 10 electric field lines are entering this cube, 10 electric field lines will be leaving this cube, such that the flux entering the cube will be exactly equal to the flux leaving the cube, and hence the total flux passing through this cube will be equal to 0. देख लीजिए बेटा और एक एग्जांपल, have a look at this example. This is example number 3. यहाँ पे ये इलेक्ट्रिक फील्ड है बेटा, that's E. इसकी जो हाइट है बेटा that's equal to h, and the radius of the cylinder is given, that's equal to r. That's equal to r. Now here we have, these are the electric field lines which are entering, and then the same number of electric field lines are leaving this cylinder as well. What about the area of projection? इसमें जो projection होगा that will be like this, that will be a circle. ठीक है ना, इसका रेडियस है r. So इसका जो एरिया है, this is the projection. What about the area of the circle? That is equal to pi r square. So what is flux entering equal to? Flux entering is minus E into what area, that's equal to pi r square. And what about flux leaving? That will be equal to plus E into pi r square. And what about the total flux? That is equal to 0. सही है ना बेटा? Okay. In the same way, for example, this is secure here. आप यहाँ से लाई डालो ऐसे, this is secure. यहाँ पे सर्कल नहीं है, it is a secure of radius r. Okay. Now have a look at this. अगर आप यहाँ से लाइट ऑन करोगे तो इसकी जो शेडो उस साइड से बनेगी, that will be a circle. उस सर्कल का एरिया क्या होता है? That is pi r square. So again the projection here, that is this. This is a circle whose radius is equal to r. This is the projection. इसका एरिया किसके बराबर होता है? pi r square. What about flux entry? That will be equal to here. Let me write it. Flux entry is equal to minus E into area, that is pi r square. What about flux leaving? That will be plus E multiplied by pi r square. What about the net flux through this? That is equal to 0. So we are done with this example. देख लीजिए बेटा एग्जांपल नंबर 5 को, दिस इज सिलेंडर whose height is equal to h and the radius is equal to r and this is electric field. ठीक है बेटा, so this is electric field lines. ठीक, now the number of electric field lines entering must be exactly equal to the number of electric field lines leaving. Now imagine for example हम क्या करेंगे बेटा, यहाँ से हमने लाइट ऑन की, जो हमने यहाँ से लाइट ऑन की, यहाँ पे एक शैडो बनेगी, उस शैडो की शेप क्या होगी, व्हाट विल बी द शेप ऑफ दैट शैडो, दैट विल बी एग्जैक्टली अ रेक्टेंगल. इस तरह से होगा बेटा, दिस इज द प्रोजेक्शन ऑफ द सिलेंडर. ठीक है ना बेटा, दिस इज द प्रोजेक्शन ऑफ द सिलेंडर. ठीक है, तो इसका जो ये वाला साइड होगा r plus r, that will be equal to r, which will be the diameter of the cylinder. Number one. Number second is that जो ये वाला साइड होगा, this will be equal to h, और इसका जो एरिया है that is equal to length into breadth, which is equal to 2r into h. And now what about flux entering? Will there be negative or positive? Obviously negative, minus e into area. Okay, so area इसका क्या है, that is minus e into 2rh. What about flux leaving? That will be equal to plus e into 2rh. And what about the total flux? The net flux passing through this will be equal to 0. The reason is that number of electric field lines entering will be exactly equal to the number of electric field lines leaving. The total electric field lines passing through the surface will be equal to 0. ठीक है, अब आपके पास क्या है बेटा, एक कोन है जिसकी हाइट दी गई है, that's equal to h, and the radius of this cone is given, that's equal to r. You tell me what will be the projection of this cone. इस कोन की प्रोजेक्शन क्या होगी? That will be obviously a circle. यहाँ से आप लाइट ऑन कर लो, यहाँ से जो फिगर बनेगा वो बनेगा बेटा सर्कल. इस सर्कल का रेडियस क्या होगा? That will be equal to r. What about the area of the circle? That is pi r square. Now you tell me what's the flux entering and what about flux leaving and what about the total flux passing through this. Flux entering will be equal to minus e multiplied by pi r square. Flux leaving will be equal to plus e multiplied by pi r square, and the total flux will be equal to 0, which is passing through this. The net flux will be equal to what? That will be equal to 0. ठीक है बेटा, again here we have a cone and these are the electric field lines which are passing through this cone. इसकी जो height है बेटा, that's equal to h, and the radius of this cone that's equal to r. Now imagine like this, ये कौन है बेटा, आपने यहाँ से लाइट डाली तो वहाँ से एक डायग्राम बनेगा. वो डायग्राम क्या होगा, उसका what will be the shape of that? That will be like this, that's a triangle. और उस triangle का जो base होगा बेटा, that will be the diameter of this, which is equal to 2r, and height of this triangle will be equal to h. Now इसका area किसके बराबर होता है? That's equal to 1/2 height base into height, 1/2 base into height. What is the base? That is 2r into h is 2rh divided by 2, तो ये किसके बराबर आएगा? RH के बराबर. So you tell me what is the flux entering through this? That's equal to minus E multiplied by RH. And what about the flux leaving through this? That is plus E multiplied by RH. And what is the total flux passing through this? That will be exactly equal to 0. ठीक है बेटा? Okay. Next, what I have done is that I have summarized all these results. इसका जो area बेटा, area that is called A square. This is secure, इसका जो प्रोजेक्शनल एरिया बनेगा that is pi r square. This is cone, इसका जो प्रोजेक्शनल एरिया बनेगा that is circle, which is pi r square. इसका भी सर्कल ही बनेगा बेटा, उसका एरिया होगा pi r square. इसका रेक्टेंगल बनेगा whose length will be equal to h and whose breadth will be equal to 2r, so area will be 2rh. ठीक है ना बेटा? Okay. So the problem boils down to calculating area of the projection. Once you are done with that, the flux is done. तो इसका जो एरिया होगा बेटा, that will be equal to what? 1/2 base in height. इसका जो height है बेटा, that's equal to h, and the base is equal to 2r. Area of the projection will be equal to r into h. So flux entry is negative, flux leaving is positive, and the total flux will be equal to 0. Very important question. Continuously questions are asked on this very problem. Next देख लीजिए बेटा, important point है, if a closed surface is placed in a region of uniform electric field, net flux through that surface will be equal to 0. That's always true. ठीक, अब ये देख लीजिए बेटा, ये example number 1 जो है, the electric field here, that is a non-uniform electric field. The electric field is a non-uniform electric field. Okay, with the function of x. ठीक है ना? Question है क्या? You will have to calculate what? Let me write down the question here. कैलकुलेट क्या करना है? कैलकुलेट फ्लक्स थ्रू द ट्यूब, नेट फ्लक्स थ्रू द ट्यूब. This is what you have to calculate. What we have to calculate is net flux through the cube. What I will do is this, I will calculate the flux entering through the cube, flux leaving through the cube, and the total flux will be the summation of the two, as simple as that. तो यहाँ पे ध्यान रखिए बेटा, electric field is given that E0 into x into I cap. I cap means that it is directed along the x-axis. तो यहाँ पे बताइए बेटा इलेक्ट्रिक फील्ड का वैल्यू यहाँ पे क्या होगा, 0, because x is equal to 0. यहाँ पे x का वैल्यू क्या है, a, तो यहाँ पे इलेक्ट्रिक फील्ड जो होगा that will be equal to E naught into a. यहाँ पे जो इलेक्ट्रिक फील्ड होगा that will be equal to what, that will be equal to E naught multiplied by twice a. ठीक है, तो यहाँ से फ्लक्स, here the field lines will enter and here the field lines will leave. तो यहाँ पे फ्लक्स होगा बेटा नेगेटिव एंड यहाँ पे फ्लक्स होगा पॉजिटिव. सो लेट मी राइट डाउन हियर व्हाट इज द फ्लक्स एंटरिंग. फ्लक्स एंटरिंग इज इक्वल टू माइनस ई मल्टीप्लाइड बाय एरिया. अब यहाँ पे आप इलेक्ट्रिक फील्ड बताइए किसके बराबर है, सर वो है ई नॉट मल्टीप्लाइड बाय ए. व्हाट अबाउट द एरिया ऑफ दिस स्क्वायर, जो स्क्वायर है इसका एरिया क्या है, इसका साइड दिया गया है दैट्स इक्वल टू ए, बिकॉज़ यहाँ x इक्वल टू a, x इक्वल टू 2a, सो साइड इज a, तो इसका जो एरिया होगा दैट विल बी इक्वल टू a स्क्वायर. So electric flux entering is equal to minus E naught multiplied by E cube. This is negative. Then what about flux leaving? Flux leaving will be equal to plus E multiplied by E. अब वहाँ पे electric field देख लीजिए बेटा. Electric field at this point and this point is not same. यहाँ पे electric field है E naught A, यहाँ पे है E naught into 2A. So the electric field will be that is E naught multiplied by twice A. What about area of the square? That's A square. तो यहाँ पे जो इलेक्ट्रिक फ्लक्स आएगा वो आएगा twice E naught multiplied by A cube. This is flux leaving. Okay. Now the net flux here I will write it down. Let me write it here. The flux total will be equal to flux entering plus flux leaving. ठीक है ना बेटा, तो फ्लक्स एंट्रिंग किसके बराबर है, माइनस ई नॉट मल्टीप्लाइड बाय ए क्यूब. व्हाट अबाउट फ्लक्स लीविंग, दैट इज ट्वाइस ई नॉट इनटू ए क्यूब. दिस प्लस दिस विल बी सिंपली इक्वल टू व्हाट, दैट विल बी ई नॉट मल्टीप्लाइड बाय ए क्यूब. दिस इज द टोटल इलेक्ट्रिक फ्लक्स पासिंग थ्रू दिस क्यूब. ऑलराइट, ओके, दैट्स माय हेड. देख लीजिए बेटा नेक्स्ट क्या है, नेक्स्ट इज द स्टेटमेंट ऑफ द गॉसेस लॉ. So next is what, the statement of the Gauss's law. Ab statement of Gauss law है क्या? So I'm sure that the area vector is crystal clear to you. Number one. Number second is that the flux is also clear to you, and we have done a good number of examples on how to calculate the electric flux, how to calculate the electric flux entering a surface, and how to calculate the electric flux leaving a surface. We are done with that. Up next देख लीजिए बेटा statement. That statement is like this, that the net electric flux through a closed surface, is equal to 1 by epsilon naught times the charge enclosed by the surface. Okay, so that the flux to a closed surface given by this equation, integration of E dot dA, this circle or this integration means a closed surface like a sphere or a cone or a cylinder or a cube, is equal to Q enclosed divided by epsilon naught. Q enclosed means what, the total charge inside the surface. This is what we call as the Gauss's law. This is the statement of the Gauss's law. Okay, तो देख लीजिए बेटा सिंपल सा प्रूफ है इसका. सो फॉर एग्जांपल हियर वी हैव दिस पॉइंट चार्ज q. ठीक, इमेजिन अ स्फीयर व्हिच इज अराउंड इट. दिस स्फीयर इज कॉल्ड एज Gaussian surface or Gaussian sphere, Gaussian surface, or you can name it Gaussian surface, whose radius is equal to what, that's equal to r. For example, it's equal to r. All right, what we'll do is that we'll try to calculate what is the flux for this surface. Once we are done with the flux, then from there we can calculate. Okay, we can prove the Gauss's law. यहाँ पे ध्यान रखिए बेटा. So the electric flux through this surface, through this closed surface, is given by this equation, isn't it? Now it is equal to integration of E into dA into cos 0 degree, isn't it? The angle between this electric field and dA vector, that's equal to 0 degree. सही है बेटा. Okay, so flux I will write like this, flux is equal to, अब देख लो बेटा इलेक्ट्रिक फील्ड ड्यू टू पॉइंट चार्ज वो किसके बराबर होता है, वो होता है k q by r स्क्वायर. ठीक है ना. एंड इलेक्ट्रिक फील्ड एट दिस पॉइंट, एट दिस पॉइंट, एट दिस पॉइंट, एट दिस पॉइंट, एवरीवेयर इट विल बी सेम. जब ये इलेक्ट्रिक फील्ड सेम होगा, सो यू कैन पुल दिस आउट इनटू इंटीग्रेशन ऑफ dA एंड cos 0 is equal to 1. What is this dA? This dA is very small area element on this sphere. All right, when you are adding all these areas on the sphere, it will give a surface area of this Gaussian sphere. So that means this is simply what, electric field multiplied by surface area or second. Now you tell me what is the value of the surface area per second. So here I will write down electric field due to point charge is equal to 1 by 4 pi epsilon naught multiplied with Q divided by R square. This is the electric field due to the positive point charge. This is the electric field due to the positive point charge. Q by R square into what is the surface area per second? That is equal to 4 pi R square. Now have a look. This 4 pi cancels. R square cancels. We are simply left with what? Q divided by epsilon naught. That's it. Hence we have proved that what we have proved is this, that the flux for a closed surface, which is represented by this equation, integration of E dot dA, is in turn equal to what? Q divided by epsilon naught. So what is the charge inside this? That is Q. So in general we can write down it is Q ENC. ENC means the charge that's enclosed or charge that's inside the Gaussian section. So this is the Gauss's law for you. अब ये Gauss's law हम क्यों पढ़ रहे हैं? Why we are? What's the motivation behind studying the Gauss's law? The reason is simple. It gives us electric field. It is used to calculate electric field due to the symmetric charge distributions. You will see that later on. देख लीजिए बेटा next क्या है? So some important points. So point number first is this, that electric field. अब तो हमने equation ये लिखी that the flux for a closed surface is given by this integration of E dot dA is equal to what? That is Q enclosed divided by epsilon naught. This is Gauss's law for you. ठीक है बेटा? This is Gauss's law for you. Now some important points. Point number 1 हमने ये लिखा बेटा, जो ये electric field यहाँ इस equation में है at any point is contributed by both the charges that are inside the Gaussian surface or outside the Gaussian surface, but the flux is always contributed by only those charges that lie inside the surface, not by those charges which are outside the Gaussian surface. तो वही तो हमने लिखा electric field is due to Q enclosed as well as Q outside. Flux is due to Q inside only, and flux depends only on the charge enclosed. This question has been directly asked in the conceptual form in NEET 2023. And the flux is independent of what? It does not depend upon the shape and size of the Gaussian surface. It does not depend upon the position of the charges inside the surface. What does that mean? For example, ये मान लीजिए this is a Gaussian surface, ठीक है? Now this is your charged particle Q1, this is your charged particle Q2, this is your charged particle Q3, this charged particle Q4, this is charged particle Q5. देख लीजिए बेटा, concentrate here. The electric field, for example, this any point which is point P. At point P, electric field will be because of Q1, Q2, Q3, Q4, Q5. But the flux to this surface will be only contributed by Q1, Q3, and Q2, not contributed by Q4 and Q5. Moreover, जो flux इसमें से होगा, that will be equal to Q1 plus Q2 plus Q3 divided by epsilon naught, and that has nothing to do with the shape and the size of this Gaussian surface and the position of the charged particles inside this Gaussian surface. It will not depend on that. Okay. Physical significance of the Gauss law is simply like this. Number 1 is that the electric monopoles exist. What we mean by that, it means that we can have separate positive charge and we can have separate negative charge. The reason is flux for a closed surface is not equal to 0. Number 1. Number 2 is that electric field lines do not form closed loops. They start from positive charge and end at negative charge. Okay, and number 6 is that if Q enclosed is equal to 0, then the flux for the closed surface is equal to 0. That is asked in NEET 2023. If the total charge inside will be 0, so the flux will be equal to what? That will be equal to 0. Now, let's do some examples on the Gauss's law. So, example number 1 आप देख लीजिए बेटा. We have to calculate what is the flux for the surface. Easy question है बेटा. Flux is simply equal to what? That's Q enclosed divided by epsilon naught. Now you tell me what's Q enclosed. These are the charges that are inside. So what are the charges inside? That is 2 plus 5 minus 3 divided by epsilon. 2 plus 5 is 7. 7 minus 3 is what? That is 2 plus 5 7. 7 minus 3 is 4. इसका जो आंसर आएगा 4 divided by epsilon naught will be the flux through this surface. Have a look at this question. ये है बेटा. This is a Gaussian surface and there is a charge. Radius is R. If the radius of the sphere is doubled, then the flux through the sphere will be doubled, halved, remain the same, quadrupled. What will happen to that? That will remain same. Because the reason is that अगर हम इस radius को double करेंगे, क्या charge, the charge which is inside, will that increase or will that decrease? That will remain same. And then you know that the flux does not depend upon the shape and size of the Gaussian surface. It will only depend on the charge enclosed. Hence, the flux through this closed surface will remain the same. Okay. These are three surfaces, you will have to write down the flux in the decreasing order. First and foremost, you write down what is Q enclosed in the surface number 1. Write down that. What is that? That is 5 plus 3 is 8. 8 minus 2, what's that? That's 6 coulomb. Write down what is Q enclosed in the surface number 2, because the flux is contributed by only that charge which lies inside. The charge that is outside, it has nothing to contribute to the flux. So this is here what? That is 6 coulomb. What about this? Here in this unique case, what is Q enclosed equal to? For the surface number 3, that is equal to what? That is 2 and 2 will cancel, minus 2 plus 2 cancel, so it's equal to what? 4 coulomb. So that means flux phi 1 will be equal to flux phi 2 and will be greater than flux phi 3 as simple as that. Clear or not? This has been asked in this question has been asked in the JEE Main 2022. ओके, आगे चलते हैं। देख लो बेटा और एक क्वेश्चन क्या है, नीट 2019 का क्वेश्चन है, कैलकुलेट द फ्लक्स टू द सरफेस। दिस इज अ डाइपोल व्हिच इज प्लेस्ड इनसाइड। व्हाट इज द नेट चार्ज ऑफ द डाइपोल? व्हाट इज Q enclosed inside this Gaussian surface? The Q enclosed is minus Q plus Q big 0. Flux through the surface will be absolutely equal to 0. So the flux will be equal to 0 through the surface. If 10 dipoles are placed inside a Gaussian surface, what is the flux? Again equal to 0. Another example, a very beautiful example, and that is famously known as the cube problem. Okay, so in this very question, what is given to you is that the charged particle is placed inside a cube. Okay, then you will have to calculate what's the flux. So देख लीजिए बेटा example है क्या? Charge Q is placed at the center of the cube. See that, have a look. The flux through the cube, and calculate the flux through the cube and the flux through each face of the cube. So per face you will have to calculate the flux. Now you tell me here, what is the total charge that's enclosed by this cube? The answer is big Q. ठीक है ना बेटा? That is cube, the total charge enclosed. Now you tell me how many faces a cube has. It has 6 faces. This is 1, opposite 2, this is 3, this one is 4, 5 and 6 faces. So how many faces are there? 6 faces. ठीक है ना बेटा? So flux through the entire cube will be equal to Q divided by epsilon naught. How many faces receive flux? इसका मुझे आंसर बताइए बेटा. इसका आंसर है क्या? इसका आंसर बेटा 6 faces receive flux. Answer is 6. When it's 6, so what will be the flux per phase? That will be total flux divided by 6. So that's equal to 5 by 6. Which is equal to Q divided by 6 epsilon naught. This is the answer. ठीक है ना बेटा? Okay, so charge enclosed is Q, and what is the flux through the cube? That will be equal to Q by epsilon naught. How many phases receive flux? 6 phases. So what will be the flux per phase? That will be equal to Q divided by 6 epsilon naught. ठीक है बेटा? B part देख लीजिए आप. Have a look at this B part. Charge Q is placed on one surface, on this very face, okay? Placed on face of a cube. Calculate flux through the cube and flux through each face of the cube. First and foremost, देख लीजिए बेटा, try to understand this problem. देखो बेटा, ये हम कैसे करेंगे? This is charge Q. मान लो बेटा, suppose that there are 10 electric field lines which are coming out of this charge. Now you tell me, out of these 10 electric field lines, how many will pass through this cube and how many electric field lines will not pass through the cube? The answer is obvious. The pi will go through this cube and the pi will move out of the cube. Simply like this. For example, this here one electric field line, this another electric field line, this another electric field line. Now these are some electric field lines which will not be passing through this cube. ठीक है ना? So you tell me, out of suppose 10 electric field lines, how many are passing through? That is 5 are passing through this cube. How many are not passing through the cube? 5 will not pass through the cube. So that means what is the charge enclosed by this cube? The charge enclosed by this cube is equal to Q divided by 2. So when the charge enclosed is Q divided by 2, what is the flux through the cube? That is Q divided by 2 epsilon naught. Now, how many faces the cube has? It has 6 faces. And how many faces receive flux? 6? Not at all. Only 5 will receive flux. One phase will not receive flux. कौन सा phase? जिस पे charge है. The flux through this phase, which is B, C, G, F, will be equal to 0. So how many phases receive flux? The answer is what? The answer is 5 phases receive flux. When the 5 phases receive flux, so the flux per phase will be total flux divided by 5. ठीक है ना? Now 5 2s are 10, so the flux will be equal to Q divided by 10 epsilon naught, which is passing through each phase. ठीक है ना? And you can write down here this one more point, and that's flux through this very phase, which is BCGF. BCGF. The flux through that phase will be equal to what? That will be equal to 0. ठीक है ना बेटा? अब आगे चलो बेटा, यहाँ पे ध्यान रखिए, concentrate here. Now there the charged particle which is placed on the edge. When the charged particle is placed on the edge, imagine that there are suppose 4 electric field lines. Out of the 4 electric field lines, only one will pass through this cube, and the remaining 3 they will be out of this cube. So what's the amount of the charge that is shared by this cube? That's Q divided by 4. The Q enclosed, that's equal to Q divided by 4. Flux will be Q divided by 4 epsilon naught. Now out of these 6 phases, how many phases will receive the flux? The adjacent phases will not receive flux. The non-adjacent phases will receive the flux. Then the flux through this ABCD, let me write it here. Flux through this surface ABCD will be equal to 0, and the flux through this surface, that is BFGC will be also equal to 0. And how many surfaces are there? The 4 phases will receive the flux. So यहाँ मैं लिखूँगा बेटा 4 phases receive flux. So 4 into 4 is 16. So the flux per phase will be 5 divided by, sorry, this is 5 divided by, wait a moment, ये क्या है यहाँ पे बेटा? It is 5 divided by 4, 5 by 4, so that will be equal to 4, 4 is 16. The answer will be Q divided by 16 epsilon naught. ठीक है ना बेटा? आगे चलते हैं. Next example देख लो बेटा. Charged particle is placed at the corner. Out of this charged particle, the charge that's enclosed in this cube will be only Q by 8. It will be equally shared by 8 different cubes. Or like this, if there are 8 electric field lines which are passing, which are coming out of this charge, out of the 8 electric field lines, only one electric field line will pass through this cube. The 7 electric field lines, they will escape the cube, they will go out of the cube. So that means the charge enclosed here is Q divided by 8. Flux is Q divided by 8 epsilon naught. Now, out of these phases, how many phases will receive flux? 3 phases will receive flux and 3 will not receive flux. इसमें जो फ्लक्स होगा बेटा, ये वाला सरफेस जो है, that is ABCD. First of all, flux through ABCD will be equal to 0. Flux through ABFE will be equal to 0, and flux through this surface, this ये वाला surface BCGF will be equal to 0. So 3 phases will receive flux and 3 phases will not receive flux. How many phases will receive flux? Answer is 3. Flux per phase will be equal to total flux divided by 3. And what's the total flux? Q by 8. 8 3s are 24. तो ये बनेगा बेटा Q divided by 24 epsilon naught will be the flux through each surface. ठीक है बेटा, यहाँ पे मैंने ये summarize किया that the charged particle placed in the center or the face edge corner, then Q enclosed will be equal to Q by 2. Then accordingly, how many phases receive flux? These. तो यहाँ पे example मैंने summarize किया बेटा. Another important example asked in JEE maths and has been copy pasted from S Verma. यहाँ आपकी text book पे है ये example. ठीक है. Charged particle यहाँ पे है बेटा at a distance of a by 2. This square is there. इस square में से आपको निकालना है बेटा what is the flux. Now simply again see that this charged particle is placed at the center of this cube. ये वाला cube है बेटा. This is the cube and it's placed inside this cube. Now what is the flux for this entire cube? What is the flux for this entire cube? The flux for this entire cube is equal to Q divided by epsilon naught, isn't it? Now this is one phase. Among the 6 phases, this is one such phase. So what is the flux per phase? That will be equal to the total flux divided by 6, which is equal to Q divided by 6 epsilon naught. This is the answer, which is Q divided by 6 epsilon naught. ठीक है बेटा, देख लो इन सारे क्वेश्चंस का एक ही आंसर बेटा. See, now imagine like this. For example, there are 6 electric field lines coming out of this. 3 will pass through this sector, isn't it? And 3 will not pass through this sector. So what is Q enclosed? Q divided by 2. In the same way, again here, 3 electric field lines will pass through the cylinder. 3 will not pass through the cylinder. What is Q enclosed? Q divided by 2. यहाँ पर भी Q enclosed Q divided by 2. What about this? Q enclosed Q divided by 2. So what about the flux? Flux for the surface will be equal to Q by 2 epsilon naught. What is the flux for this? Q divided by 2 epsilon naught. And what is the flux for this? That is Q divided by 2 epsilon naught. What about this? That is Q divided by 2 epsilon naught. Hence, we have calculated flux through each of these surfaces. So I'm sure that this example is crystal clear to you. Okay, so my dear students, I'll stop here. Okay, so in the next meeting we'll be discussing the applications of Gauss's law. You take care of yourselves. See you then.
Thank you, my cameraman, Mr. Abdul Majid Kaikupar.